Over the past several podcasts, we have explored how cities measure, analyze, and manage urban forests. We discussed urban tree canopy, species diversity, ecosystem services, public health, and community engagement. These topics focus on managing the urban forest as a population of trees across an entire city. But managing the urban forest also requires understanding how individual trees are cared for. Urban forestry and arboriculture are closely connected. Urban forestry focuses on the management of tree populations, while arboriculture focuses on the care and maintenance of individual trees. Together, these two disciplines help cities maintain healthy, resilient urban forests. Arboricultural practices include a wide range of activities such as planting trees, pruning branches, diagnosing pests and diseases, improving soil conditions, managing tree risk, protecting trees during construction. These activities require technical knowledge and professional standards to ensure that tree care is performed safely and effectively. Without proper arboricultural practices, urban trees may develop structural problems, become hazardous, or fail to reach maturity. This is why professional standards play such an important role in tree care. Across North America, arborists follow a set of industry standards known as ANSI A300 standards. ANSI stands for the American National Standards Institute, which develops voluntary industry standards for many professions. The ANSI A300 standards provide guidelines for professional tree care operations. These standards cover topics such as pruning, soil management, tree support systems, lightning protection, and tree risk assessment. The goal of these standards is to promote safe, consistent, and effective arboricultural practices. While ANSI standards describe what should be done, arborists also rely on additional guidance known as Pest Management Practices, often abbreviated as BMPs. Pest management practices provide more detailed information about how to perform specific arboricultural tasks. For example, BMP manuals may explain how to perform structural pruning, how to improve soil conditions, or how to conduct a tree risk assessment. Together, ANSI standards and best management practices provide the professional framework that guides modern arboriculture. Urban forestry programs rely on these practices to maintain healthy tree populations across the city. Proper pruning improves tree structure and reduces storm damage risk. Soil management improves root health and long-term tree stability. Careful planting practices increase the survival rates of young trees. These practices help ensure that trees planted today will grow into the mature canopy trees that provide long-term environmental benefits. For the ISA Urban Forest Professional Exam, remember the difference between urban forestry and arboriculture. Urban forestry focuses on managing tree populations across a city, while arboriculture focuses on the care and maintenance of individual trees. Exam questions may also emphasize that ANSI A300 standards and ISA best management practices guide professional arboricultural work. Today we introduce the arboricultural practices that support healthy urban trees. While urban forestry focuses on planning and managing tree populations, arboriculture provides the technical skills needed to care for individual trees. In the next podcast, we'll take a closer look at tree biology fundamentals for arboriculture. In the previous episode, we introduced arboricultural practices and how they support the health and function of the urban forest. Before we explore specific practices like pruning, planting, or risk assessment, we need to understand something more fundamental. We need to understand how trees actually function. Because every decision an arborist makes is based on tree biology. If you understand how a tree grows, how it responds to stress, and how it defends itself, you can make better decisions in the field. If you do not, even well-intentioned actions can cause long-term harm. So today, we're going to step back and look at the basics of tree biology, not from a textbook perspective, but from a practical arborist's perspective. What do you actually need to know to care for trees in an urban environment? Let's start with structure. A tree has three main parts: roots, trunk, and crown. Each part has a specific role. The roots anchor the tree and absorb water and nutrients from the soil. The trunk provides structural support and transports water and sugars. The crown, which includes branches and leaves, is where photosynthesis happens. Photosynthesis is one of the most important processes in tree biology. Leaves use sunlight, carbon dioxide, and water to produce sugars. These sugars are the tree's energy source. They fuel growth, maintenance, and defense. This is why leaf area matters. More healthy leaves generally mean more energy production. And that energy supports everything else the tree does. Now let's talk about movement within the tree. Trees move water and nutrients upward through a tissue called xylem. Water is pulled from the roots to the leaves through a process driven by evaporation, also called transpiration. At the same time, sugars produced in the leaves move throughout the tree through another tissue called phloem. This movement allows energy to be distributed to roots, stems, and growing tissues. Understanding this system helps explain why certain practices matter. For example, when too many leaves are removed during pruning, the tree loses energy production capacity. When roots are damaged during construction, the tree loses its ability to absorb water and nutrients. Everything is connected. Now let's look at growth. Trees grow in two main ways. They grow in length, and they grow in diameter. Length growth happens at the tips of branches and roots. Diameter growth happens in a layer called the cambium. The cambium produces new cells that increase the thickness of the trunk and branches. This is what creates annual growth rings. These growth patterns are important for arborists. They help explain how trees respond to pruning. When you remove a branch, the tree does not heal like humans do. Instead, it seals off the wound through a process called compartmentalization. This process was described in a model known as CODIT, which stands for Compartmentalization of Decay in Trees. Trees create barriers that limit the spread of decay. They do not repair damaged tissue. They isolate it. This is why proper pruning cuts are critical. A correct cut allows the tree to effectively compartmentalize the wound. A poor cut can lead to decay spreading further into the tree. Now let's talk about roots, because roots are often misunderstood. Most tree roots are located in the upper layers of soil. They spread outward, often far beyond the canopy. Roots need oxygen, water, and space. In urban environments, these conditions are often limited. Soil compaction reduces oxygen availability. Restricted planting spaces limit root growth. Poor soil conditions reduce water infiltration. This is why urban trees often struggle. Not because of what we see above ground, but because of what is happening below ground. Understanding root systems is essential for arboriculture. It influences how we plant trees, how we manage soil, and how we protect trees during construction. For the ISA Urban Forest Professional Exam, remember that arboricultural practices are grounded in tree biology. You should understand how trees produce and use energy, how water and nutrients move through the tree, how trees grow in height and diameter, how trees respond to injury through compartmentalization, and how root systems function in urban environments. Many exam questions will test your ability to apply biological concepts to real-world situations. Tree biology is the foundation of arboriculture. Every pruning cut, every planting decision, and every management action should be based on an understanding of how trees function. In the next podcast, we'll build on this foundation by looking at how trees respond to pruning, and how arborists use pruning to guide structure, reduce risk, and improve long-term tree health. In the last podcast, we explored tree biology and how trees grow, move resources, and respond to injury. Today, we're going to apply that knowledge to one of the most important arboricultural practices: tree pruning. Pruning is one of the most common and most misunderstood activities in arboriculture. When done correctly, it improves tree structure, reduces risk, and supports long-term health. When done incorrectly, it can weaken the tree, create defects, and accelerate decline. So the question becomes, what is the purpose of pruning? Pruning is not about making trees look neat. It is about managing structure and function. There are several primary objectives of pruning: structural improvement, risk reduction, clearance, and health maintenance. Let's start with structure. Young trees often develop competing leaders, narrow branch angles, or poorly spaced branches. These structural issues can lead to failure later in the tree's life. Structural pruning focuses on guiding the tree's architecture early. This often means selecting a dominant leader, removing or reducing competing stems, and encouraging well-spaced scaffold branches. The goal is to create a strong, stable structure that can support future growth. Next is risk reduction. As trees mature, defects such as dead branches, cracks, or weak attachments may develop. Pruning can reduce the likelihood of branch failure by removing deadwood, reducing weight on overextended limbs, and improving branch attachments. It's important to understand that pruning does not eliminate risk entirely, but it can significantly reduce it. Clearance pruning is another common objective. This type of pruning ensures that trees do not interfere with infrastructure. For example, branches may be pruned to maintain clearance from roads, sidewalks, buildings, or utility lines. Clearance pruning should be done carefully. Over-pruning for clearance can damage tree structure and reduce canopy function. Health-related pruning involves removing dead, diseased, or damaged branches. This helps prevent the spread of decay and improves overall tree condition. However, it's important to note that pruning alone does not cure most diseases. It is only one part of an overall management strategy. Now let's talk about how trees respond to pruning. As we discussed in the previous episode, trees do not heal. They compartmentalize. When a branch is removed, the tree forms barriers to limit the spread of decay. This makes proper pruning cuts extremely important. The most important concept here is the branch collar. The branch collar is the swollen area where a branch meets the trunk or another branch. It contains specialized tissue that helps the tree seal the wound. A proper pruning cut is made just outside the branch collar, not flush with the trunk, and not leaving a long stub. A flush cut removes the branch collar and reduces the tree's ability to compartmentalize. A stub cut leaves dead tissue that can become a point of decay. Both should be avoided. Now let's look at pruning intensity. One of the most common mistakes in arboriculture is over-pruning. Removing too much canopy reduces the tree's ability to produce energy. This can stress the tree and lead to excessive sprouting. A general guideline is to avoid removing more than 25% of the live canopy in a single pruning cycle. In many cases, less is better. Pruning should be gradual and intentional. Timing is also important. Pruning can be done at different times of the year depending on the objective. For many species, structural pruning is best done during the dormant season. However, dead or hazardous branches can be removed at any time. Understanding species-specific responses is also important. Some trees respond well to pruning. Others are more sensitive. Arborists must consider species, age, condition, and site when making pruning decisions. For the ISA Urban Forest Professional exam, focus on the objectives and principles of pruning. You should understand the difference between structural, risk, clearance, and health pruning, the importance of the branch collar, the concept of compartmentalization, the risks of over-pruning, and how pruning supports long-term tree structure. Many questions will test your ability to identify proper pruning practices and avoid common mistakes. Pruning is one of the most powerful tools in arboriculture, but it must be used carefully. Every cut affects how a tree grows, how it defends itself, and how it functions over time. In the next podcast, we'll take a closer look at structural pruning in young trees, and how early decisions can shape the future of the urban forest. In the previous podcast, we introduced the general principles of pruning and the importance of making proper cuts. Today, we're going to focus on one of the most important applications of pruning in arboriculture: structural pruning of young trees. If there is one place where arborists can have the greatest long-term impact, it is during the early years of a tree's life, because problems that develop in young trees often become failures in mature trees. Structural pruning is about guiding the tree's architecture while it is still developing. The goal is to create a strong, stable structure that can support the tree as it grows larger. Let's start with one of the most important concepts: the central leader. Many tree species naturally develop a dominant central stem. This central leader provides vertical structure and stability. However, in urban environments, trees often develop competing leaders. These are multiple stems of similar size growing upward from the same point. Competing leaders can create weak attachment points. Over time, these attachments may fail, especially during storms. Structural pruning focuses on selecting a single dominant leader. Competing stems are reduced or removed to encourage one main trunk. This creates a stronger and more stable tree structure. Next, let's talk about branch spacing. Branches should be distributed along the trunk in a balanced and well-spaced pattern. If branches are too close together, they can compete for space and create weak attachments. If branches are too large relative to the trunk, they can become structurally dominant. A general guideline is to maintain a good ratio between branch size and trunk size. Branches that are too large compared to the trunk may need to be reduced. Another important concept is branch angle. Branches that attach at narrow angles are more likely to develop included bark. Included bark occurs when bark becomes trapped between two stems. This weakens the attachment and increases the likelihood of failure. Structural pruning encourages wider branch angles. This creates stronger attachments and reduces the risk of breakage. Now let's talk about temporary branches. Temporary branches are small branches that are intentionally left on the lower trunk of a young tree. These branches help the tree develop taper and protect the trunk from sunscald. Over time, these branches are gradually removed as the tree matures. This gradual removal helps maintain tree health while guiding structure. Another key principle is gradual pruning. Structural pruning is not a one-time event. It is a process that takes place over several years. Each pruning cycle makes small adjustments to guide the tree's development. Removing too much at once can stress the tree and reduce growth. Instead, arborists make incremental changes over time. This approach supports both structure and health. It's also important to recognize that not all defects can be fully corrected. In some cases, pruning can only reduce the likelihood of failure rather than eliminate it. This is why early intervention is so important. The earlier structural issues are addressed, the easier they are to manage. Now let's connect this to long-term urban forest management. Trees in cities often grow in challenging conditions. They are exposed to wind, restricted space, and human activity. If a tree develops poor structure early in life, it may become a liability later. This can lead to increased maintenance costs, higher risk, and premature removal. Structural pruning helps prevent these problems. It is an investment in the future of the urban forest. A well-structured tree is more likely to survive storms, require less maintenance, and provide long-term benefits. For the ISA Urban Forest Professional exam, understand the key goals of structural pruning. You should be able to identify the importance of a dominant central leader, the risks of competing leaders, the role of branch spacing and size, the impact of branch angle and included bark, and the concept of gradual pruning over time. Questions may focus on recognizing structural defects and selecting appropriate pruning strategies. Structural pruning is about thinking ahead. It's about shaping the tree not just for today, but for decades into the future. The decisions made during the early years of a tree's life will determine its strength, stability, and longevity. In the next podcast, we'll shift from young trees to mature trees and explore how pruning is used to manage risk, maintain structure, and extend the life of established trees. In the previous podcast, we focused on structural pruning in young trees and how early decisions shape long-term stability. Today, we're shifting our focus to mature trees, and more specifically, how pruning is used to manage risk in established urban trees. Mature trees are some of the most valuable assets in the urban forest. They provide the greatest ecosystem services. They offer the most shade, the most cooling, and the highest levels of carbon storage. But with size comes complexity, and with complexity comes risk. As trees grow larger, their branches become heavier, their structure more complex, and their exposure to environmental forces increases. This means that managing mature trees is not just about growth. It's about stability and safety. Pruning mature trees is fundamentally different from pruning young trees. With young trees, the goal is to guide structure. With mature trees, the goal is to manage existing structure and reduce risk. One of the most common objectives in mature tree pruning is deadwood removal. Dead branches no longer have structural strength. They are more likely to fail and fall, especially during wind or storms. Removing deadwood reduces the risk of branch failure and improves overall tree safety. Another important objective is reducing end weight. Over time, branches may extend far from the trunk. These long, heavy limbs can create leverage forces that increase the risk of failure. Reduction pruning shortens these branches. This reduces mechanical stress and improves structural stability. It's important to understand that reduction pruning should be done carefully. Cuts should be made back to lateral branches that are large enough to assume the terminal role. This helps maintain natural form and reduces excessive sprouting. Now let's talk about defects. Mature trees may develop structural defects such as cracks, cavities, decay, or weak branch attachments. Pruning can help manage these defects by reducing load on affected areas. However, pruning is not always a complete solution. In some cases, additional measures such as cabling, bracing, or even removal may be necessary. This is where risk assessment becomes critical. Urban arborists are responsible for evaluating the likelihood of tree failure and the potential consequences. This involves looking at both the condition of the tree and the targets around it. A target could be a person, a building, a roadway, or any area where failure could cause damage or injury. Risk is often described as a combination of three factors: the likelihood of failure, the likelihood of impact, and the severity of consequences. Pruning can influence the likelihood of failure. For example, removing a large dead branch reduces the chance that it will fall. Reducing the weight of a heavy limb reduces the stress on that limb. But pruning does not eliminate all risk. It is one tool among many. Another important consideration in mature tree pruning is pruning intensity. As we discussed earlier, removing too much canopy can stress the tree. In mature trees, this can lead to decline, increased susceptibility to pests, and excessive sprouting. Sprouting often produces weakly attached shoots that can create future structural problems. This is why moderate, targeted pruning is preferred. The goal is to reduce risk while preserving as much functional canopy as possible. Timing also plays a role. While dead or hazardous branches can be removed at any time, large pruning operations should consider seasonal factors. Some species respond better to pruning during dormancy. Others may be more susceptible to disease if pruned at certain times. Understanding species-specific responses is important for effective management. For the ISA Urban Forest Professional Exam, focus on the relationship between pruning and risk management. You should understand the purpose of deadwood removal, the concept of end weight reduction, how pruning reduces mechanical stress, the role of defects in tree risk, and the limits of pruning as a risk mitigation tool. You may be asked to evaluate scenarios and determine appropriate pruning strategies. Pruning mature trees is about balance. It's about reducing risk without compromising the tree's health and function. It's about making careful decisions that protect both people and the long-term value of the urban forest. In the next podcast, we'll move from pruning to planting and explore how proper tree planting sets the foundation for long-term success in arboriculture. In the previous podcast, we discussed how pruning is used to manage mature trees and reduce risk. Now we're shifting focus to one of the most critical stages in a tree's life: planting. Because no matter how well we prune or maintain a tree later, if it is planted incorrectly, it will struggle from the very beginning. Tree planting is one of the most common arboricultural practices, but it is also one of the most frequently done incorrectly, and those early mistakes can affect a tree for its entire life. So today, we're going to focus on how to get planting right from the start. Let's begin with one of the most important concepts, site selection. Before a tree is ever planted, the site must be evaluated. This includes soil conditions, available space, sunlight, drainage, and potential conflicts with infrastructure. Urban environments often present limited rooting space, compacted soils, and competition with utilities. Selecting a species that is appropriate for the site is critical. The phrase right tree, right place is fundamental in arboriculture. A tree that outgrows its space will create long-term maintenance issues and may eventually need to be removed. Now let's talk about the planting hole. A common misconception is that deeper holes are better. In reality, planting depth is one of the most critical factors in tree survival. Trees should be planted so that the root flare is visible at the soil surface. The root flare is the point where the trunk transitions into roots. If a tree is planted too deeply, the trunk may remain buried, leading to poor oxygen exchange and increased risk of decay. In many nursery trees, the root flare is not immediately visible. Soil or container media may need to be removed to locate it. This step is often overlooked, but it is essential. The planting hole should be wide, not deep. A wide hole loosens the surrounding soil and allows roots to expand outward more easily. The depth should match the height of the root ball. Planting too deep is one of the most common and harmful mistakes. Next, let's discuss backfilling. In most cases, the soil that was removed from the hole should be used as backfill. Adding excessive amendments can create differences between the planting hole and surrounding soil. This can discourage roots from growing outward. The goal is to encourage roots to establish into the native soil. Now let's look at mulching. Mulch is extremely beneficial when applied correctly. It helps retain soil moisture, moderate temperature, and reduce competition from weeds. However, mulch must be applied properly. It should be placed in a ring around the tree, ideally 2 to 4 inches deep. It should not be piled against the trunk. This is often referred to as a mulch volcano. Mulch against the trunk can lead to moisture buildup, decay, and pest problems. Now let's talk about watering. Newly planted trees require consistent watering during the establishment period. This period may last 1 to 3 years depending on species and site conditions. Watering should be deep and infrequent, rather than shallow and frequent. The goal is to encourage roots to grow deeper into the soil. Staking is another consideration. Not all trees require staking. Staking may be necessary in areas with strong winds or unstable soil. However, excessive or improper staking can limit trunk movement. Movement is important because it helps the tree develop strength. If staking is used, it should be temporary and removed as soon as the tree is stable. Finally, let's connect planting to long-term outcomes. A properly planted tree has a much higher chance of survival. It establishes faster, grows stronger, and requires less corrective maintenance. An improperly planted tree may struggle for years. It may develop structural problems, decline prematurely, or fail entirely. For the ISA Urban Forest Professional Exam, understand the fundamentals of proper planting. You should know the importance of site selection, the concept of right tree, right place, proper planting depth and root flare visibility, the role of wide planting holes, correct mulching techniques, and the basics of watering and staking. Many questions will focus on identifying common planting mistakes. Tree planting is the foundation of the urban forest. Every tree that will one day provide shade, cooling, and environmental benefits starts at this stage. Getting it right from the beginning makes everything that follows more successful. In the next podcast, we'll continue building on this by exploring soil management and how soil conditions directly influence tree health and long-term survival. In the previous podcast, we focused on proper tree planting and how early decisions affect long-term success. Today, we're going to take a deeper look at something that often determines whether a tree thrives or struggles: soil. Because while we tend to focus on what we see above ground, the most important activity in a tree's life is happening below ground. Roots are responsible for anchoring the tree, absorbing water and nutrients, and storing energy. And all of that depends on soil conditions. In urban environments, soil is often one of the most limiting factors for tree growth. So understanding soil management is essential for arboriculture. Let's start with the basics. Healthy soil contains 3 critical components: air, water, and mineral particles. In a balanced soil, there is enough space between particles to allow oxygen and water to move freely. This space is called pore space. Roots need oxygen to function. Without it, root growth slows or stops. One of the most common problems in urban soils is compaction. Soil compaction occurs when soil particles are pressed together, reducing pore space. This can happen from foot traffic, vehicle traffic, construction activity, or heavy equipment. When soil is compacted, it becomes dense and hard. Water has difficulty infiltrating. Oxygen levels decrease. Roots struggle to grow, and the tree becomes stressed. Compaction is one of the primary reasons urban trees fail to thrive. Another common issue is limited rooting space. In natural environments, tree roots can spread widely. But in cities, roots are often confined by sidewalks, roads, buildings, and underground utilities. This restriction limits the tree's ability to access water and nutrients. It also affects stability. A tree with a restricted root system is more vulnerable to drought and wind damage. Now let's talk about soil structure. Soil structure refers to how soil particles are arranged. Good soil structure allows for both drainage and water retention. Poor structure leads to either waterlogged conditions or excessively dry soil. Both extremes are harmful to tree roots. Urban soils are often disturbed and lack natural structure. Improving soil structure is a key part of urban tree management. One method used to improve soil conditions is soil aeration. Aeration involves creating small openings in the soil to increase oxygen availability and reduce compaction. This can be done mechanically using tools that penetrate the soil. Aeration helps restore pore space and improves root function. Another approach is the addition of organic matter. Organic matter improves soil structure, increases water retention, and supports beneficial microorganisms. These microorganisms play a role in nutrient cycling and soil health. Mulching also contributes to soil improvement. As mulch breaks down, it adds organic material to the soil. Mulch also protects the soil surface from compaction and temperature extremes. Now let's look at advanced soil management techniques. In highly constrained urban environments, specialized systems may be used. Structural soils are engineered to support pavement while allowing root growth. Suspended pavement systems create space beneath sidewalks for soil and root expansion. These systems are designed to balance infrastructure needs with tree health. Understanding soil is not just about improving growth. It is also about preventing problems. For example, poor drainage can lead to root rot. Excessively dry soils can lead to drought stress. Soil pH can affect nutrient availability. All of these factors influence tree health. For the ISA Urban Forest Professional Exam, focus on how soil conditions affect tree health. You should understand the importance of pore space, the effects of soil compaction, the impact of limited rooting space, the role of organic matter in mulching, and basic soil improvement techniques. Many questions will test your ability to identify soil-related problems and appropriate solutions. Soil is the foundation of tree health. If the soil is poor, the tree will struggle. If the soil is healthy, the tree has a much greater chance of success. In the next podcast, we'll build on this by exploring irrigation and water management, and how water availability influences tree growth and survival in urban environments. In the previous podcast, we explored soil management and how soil conditions directly influence root health. Today, we're going to build on that foundation by focusing on another critical factor in tree survival and growth: water. Because no matter how good the soil is, without proper water availability, trees cannot function. Water plays a central role in nearly every biological process in a tree. It is essential for photosynthesis, nutrient transport, temperature regulation, and overall cellular function. Understanding how trees use water and how to manage it is a key part of arboricultural practice. Let's start with how trees use water. Water is absorbed by roots and transported upward through the xylem. As water moves through the tree, it eventually reaches the leaves. There, it is used in photosynthesis and also lost through a process called transpiration. Transpiration is the evaporation of water from leaf surfaces. This process creates a pulling force that helps move water from the roots to the leaves. It also helps cool the tree. Because of this system, a continuous supply of water is necessary for tree function. Now let's talk about water availability in urban environments. Urban trees often face inconsistent water conditions. In some cases, water is limited due to compacted soils, restricted rooting space, or drought. In other cases, water may be excessive due to poor drainage or over-irrigation. Both extremes can cause problems. Drought stress is one of the most common challenges for urban trees. When water is limited, trees close their stomata to reduce water loss. This also limits photosynthesis. Growth slows, and the tree becomes more vulnerable to pests and disease. Symptoms of drought stress may include leaf wilting, early leaf drop, and dieback. On the other hand, excessive water can be just as harmful. Waterlogged soils reduce oxygen availability. Roots require oxygen to function. Without it, root systems can decline, and root rot may develop. This highlights an important concept. It is not just the presence of water that matters. It is the balance between water and oxygen in the soil. Now let's talk about irrigation practices. Newly planted trees have the highest water demand. During the establishment period, roots are limited and cannot access large volumes of soil. This means watering must be consistent and intentional. A general guideline is deep, infrequent watering. This encourages roots to grow deeper into the soil rather than staying near the surface. Shallow, frequent watering can lead to weak root systems. Established trees typically require less frequent irrigation. However, during periods of drought, supplemental watering may still be necessary. The amount and frequency of watering depend on several factors. These include species, soil type, climate, and tree size. Sandy soils drain quickly and may require more frequent watering. Clay soils retain water longer but may also become waterlogged. Mulching plays an important role in water management. Mulch helps retain soil moisture, reduces evaporation, and moderates soil temperature. It also reduces competition from grass and weeds. Now let's consider irrigation systems. In urban landscapes, irrigation may be delivered through manual watering, drip systems, or automatic irrigation systems. Drip irrigation is often preferred because it delivers water slowly and directly to the root zone. This reduces waste and improves efficiency. However, irrigation systems must be monitored. Overwatering can be just as damaging as underwatering. Understanding soil moisture is key. Arborists often use simple methods such as soil probes or visual inspection to assess moisture levels. More advanced systems may use soil moisture sensors. For the ISA Urban Forest Professional Exam, focus on how water availability affects tree health. You should understand how water moves through the tree, the difference between drought stress and waterlogging, the concept of deep, infrequent watering, the role of soil type in water retention, and how irrigation supports tree establishment. Many questions will test your ability to identify proper watering practices and recognize signs of water-related stress. Water is one of the most important resources for urban trees. Managing it correctly can mean the difference between survival and decline. In the next podcast, we'll look at fertilization and nutrient management, and how nutrients support tree growth and overall health in urban environments. In the previous podcast, we discussed irrigation and how water availability affects tree health and survival. Today, we're going to look at another key factor in tree growth, nutrients. Because while water moves through the tree and supports biological processes, nutrients are what allow those processes to occur. They are the building blocks of growth. But here's something important to understand. Fertilization is often misunderstood in arboriculture. Many people assume that adding fertilizer automatically improves tree health, but that is not always the case. In fact, unnecessary or improper fertilization can do more harm than good. So today, we're going to focus on when fertilization is needed, how it works, and how to apply it correctly. Let's start with the basics. Trees require a range of nutrients to grow and function. The most important nutrients are often referred to as macronutrients. These include nitrogen, phosphorus, and potassium. Nitrogen is essential for leaf growth and photosynthesis. Phosphorus supports root development and energy transfer. Potassium helps regulate water movement and overall plant function. There are also micronutrients such as iron, manganese, and zinc. These are required in smaller amounts, but are still essential for proper growth. In natural forest systems, nutrients are continuously recycled. Leaves fall to the ground, decompose, and return nutrients to the soil. In urban environments, this cycle is often disrupted. Leaves are removed, soils are disturbed, and organic matter is limited. As a result, nutrient availability may be reduced. However, this does not automatically mean that fertilization is required. The first step in nutrient management is assessment. Before applying fertilizer, arborists should determine whether a deficiency actually exists. This can be done through soil testing or visual assessment. Soil tests provide information about nutrient levels, pH, and soil composition. Visual symptoms may include chlorosis, which is yellowing of leaves, or poor growth. However, it is important to recognize that not all symptoms are caused by nutrient deficiencies. Problems such as compaction, drought stress, or root damage can produce similar symptoms. This is why proper diagnosis is critical. If fertilization is needed, the next step is selecting the appropriate type. There are two main categories: fast-release fertilizers and slow-release fertilizers. Fast-release fertilizers provide nutrients quickly. However, they can also leach away quickly and may lead to excessive growth. Slow-release fertilizers provide nutrients over time. They are generally preferred in arboriculture because they provide a steady supply without overwhelming the tree. Now let's talk about application methods. Fertilizers can be applied in several ways. Surface application is one of the simplest methods. Fertilizer is spread over the soil surface and watered in. Soil injection involves placing fertilizer directly into the root zone. This can improve nutrient availability in compacted soils. There are also foliar applications, where nutrients are applied directly to leaves. However, this is typically used for specific deficiencies rather than general fertilization. It's important to apply fertilizer at the correct rate. Overfertilization can lead to excessive shoot growth, weak structure, and increased susceptibility to pests. It can also contribute to environmental problems, such as nutrient runoff. Now let's connect fertilization to overall tree health. Fertilization is not a substitute for proper soil management. If soil conditions are poor, adding nutrients alone will not solve the problem. In many cases, improving soil structure and organic matter is more effective than adding fertilizer. Mulching, composting, and soil aeration often provide longer-lasting benefits. For the ISA Urban Forest Professional Exam, understand the role of nutrients in tree health. you should know. The function of major nutrients like nitrogen, phosphorus, and potassium. The importance of soil testing before fertilization. The difference between slow-release and fast-release fertilizers, and the risks of over-fertilization. Questions may focus on identifying when fertilization is appropriate and selecting proper methods. Fertilization is a tool, but like all tools in arboriculture, it must be used carefully and with purpose. Understanding when and how to apply nutrients is essential for supporting healthy tree growth. In the next podcast, we'll shift from nutrients to protection and explore how arborists protect trees during construction and site development. In the previous podcast, we explored fertilization and nutrient management and how nutrients support tree growth. Today, we're shifting to a critical and often overlooked aspect of arboriculture: tree protection during construction. Because while planting and maintenance are important, some of the greatest damage to urban trees happens during development. Construction activities can have severe and lasting impacts on trees, and in many cases, the damage is not immediately visible. A tree may appear healthy after construction, but decline can begin months or even years later. So understanding how to protect trees during construction is essential. Let's start with the most important concept: the root zone. The majority of a tree's roots are located in the upper layers of soil. These roots extend outward, often well beyond the canopy. This area is sometimes referred to as the critical root zone, or CRZ. The critical root zone is the area around the tree that must be protected to maintain tree health. A common guideline is that the CRZ extends 1 foot outward for every inch of trunk diameter. For example, a tree with a trunk diameter of 10 inches may have a critical root zone with a radius of 10 feet. Within this area, root damage can significantly affect tree stability and health. Now let's talk about the types of damage that occur during construction. One of the most common issues is soil compaction. Heavy equipment moving over the soil compresses it. This reduces pore space, limits oxygen availability, and restricts root growth. Compacted soil can remain a problem long after construction is complete. Another major issue is root cutting. Excavation for foundations, utilities, or sidewalks often cuts through roots. When large roots are severed, the tree loses its ability to absorb water and nutrients. It may also lose structural stability. This can increase the risk of failure. Changes in soil grade are also important. Adding soil over the root zone can reduce oxygen availability. Removing soil can expose roots and reduce stability. Both scenarios can stress or damage the tree. Now let's look at protection strategies. One of the most effective methods is establishing a tree protection zone. This is a designated area around the tree that is fenced off to prevent disturbance. The protection zone should ideally match or exceed the critical root zone. Within this area, no equipment, materials, or excavation should be allowed. Clear communication is essential. Construction crews must understand the importance of these protection zones. Signage and physical barriers help ensure compliance. In some cases, construction must occur within or near the root zone. When this happens, special techniques may be used. Air excavation tools can be used to expose roots without cutting them. Root pruning may be performed in a controlled manner before construction begins. Protective mats may be used to reduce soil compaction. Another important concept is pre-construction planning. Urban foresters and arborists should be involved early in the design process. This allows for adjustments that can minimize tree impacts. For example, adjusting building placement or utility routing can help preserve existing trees. Post-construction care is also critical. Trees that have experienced stress during construction may require additional watering, mulching, and monitoring. Early intervention can improve survival. Now let's connect this to urban forest management. Mature trees are some of the most valuable assets in the urban forest. Losing them during construction can significantly reduce canopy and ecosystem services. Protecting existing trees is often more effective than planting new ones. For the ISA Urban Forest Professional Exam, focus on how construction affects trees. You should understand the concept of the critical root zone, the effects of soil compaction and root cutting, the impact of grade changes, and the importance of tree protection zones. Questions may involve identifying proper protection measures during development. Construction is one of the greatest threats to urban trees, but with proper planning and protection, many of these impacts can be avoided. In the next podcast, we'll continue with tree protection by looking at tree support systems, including cabling and bracing, and how arborists manage structural stability in high-risk trees. In the previous podcast, we discussed how to protect trees during construction and the importance of preserving root systems and soil conditions. Today, we're going to focus on another important arboricultural practice: tree support systems, specifically cabling and bracing. These systems are used to provide supplemental support to trees with structural weaknesses. In urban environments, trees often grow in conditions that increase the likelihood of structural defects. These may include poor pruning history, restricted space, storm damage, or natural growth patterns. When these defects are identified, arborists must decide how to manage the risk. In some cases, pruning alone is not enough, and that's where support systems come in. Let's start with cabling. Cabling involves installing flexible steel cables between branches or leaders in the upper canopy. The goal is to reduce movement and limit the likelihood of failure. Cables do not hold branches rigidly in place. Instead, they allow limited movement while reducing excessive stress. Cabling is often used in trees with multiple leaders. If two stems are growing close together and forming a weak attachment, a cable can help reduce the forces acting on that union. This is especially important during high winds or storms. Now let's look at bracing. Bracing involves installing rigid rods through weak branch unions or cracks. Unlike cables, braces provide direct structural support. They are typically installed lower in the tree, closer to the area of weakness. Bracing is often used when a crack or split has already developed. The rod helps hold the structure together and prevents further separation. Cabling and bracing are often used together. For example, a tree with a weak union may be braced to stabilize the connection and cabled to reduce movement in the canopy. This combination provides both rigidity and flexibility. Now let's talk about when these systems are appropriate. Support systems are typically used when a tree has value that justifies preservation. This may include large mature trees, historically significant trees, or trees in prominent locations. If a tree has a defect but still provides significant benefits, support systems can extend its useful life. However, these systems are not permanent solutions. They require regular inspection and maintenance. Cables may need to be adjusted or replaced over time. Hardware can degrade, and the tree itself continues to grow and change. This means that trees with support systems must be monitored regularly. Another important consideration is installation. Support systems must be installed correctly to be effective. Improper installation can cause additional damage. For example, placing hardware incorrectly can create new points of weakness or interfere with natural growth. This is why cabling and bracing should only be performed by trained professionals. It's also important to understand the limitations of support systems. They reduce risk. They do not eliminate it. In some cases, the level of risk may still be unacceptable. In those situations, removal may be the better option. Now let's connect this to overall risk management. Support systems are one of several tools available to arborists. They are used alongside pruning, monitoring, and site management. The goal is always to balance safety with preservation. For the ISA Urban Forest Professional Exam, understand the purpose and limitations of support systems. You should know the difference between cabling and bracing, when each system is used, the importance of inspection and maintenance, and the fact that support systems reduce, but do not eliminate, risk. Questions may involve identifying appropriate management strategies for trees with structural defects. Tree support systems allow arborists to preserve valuable trees that might otherwise be removed. They are a way of managing risk while maintaining the benefits of mature trees. In the next podcast, we'll shift to another critical area of arboriculture, tree risk assessment, and how arborists evaluate the likelihood of failure and potential consequences. In the previous podcast, we explored tree support systems and how cabling and bracing can help manage structural weaknesses. Today, we're going to focus on one of the most important responsibilities in arboriculture, tree risk assessment. Because in urban environments, trees exist near people, buildings, roads, and infrastructure. And that means arborists must constantly evaluate safety. Tree risk assessment is the process of evaluating the likelihood that a tree or tree part will fail, the likelihood that it will impact a target, and the severity of the consequences if it does. It is not about determining whether a tree is safe or unsafe. Instead, it is about understanding and managing levels of risk. Let's break this down into 3 key components. First, likelihood of failure. This refers to the probability that a tree, or part of a tree, will fail within a given time frame. Factors that influence likelihood of failure include structural defects such as cracks, cavities, or weak branch attachments, decay within the trunk or roots, dead branches, leaning trees with unstable root systems, and environmental conditions such as wind exposure. Second, likelihood of impact. Even if a tree or branch fails, it only becomes a significant concern if it strikes something. A target could be a person, a building, a vehicle, or an area where people frequently gather. A tree in a remote natural area may have a high likelihood of failure, but low likelihood of impact. A tree over a busy sidewalk may have a much higher level of risk. Third, consequences of failure. This refers to the severity of the outcome if a failure occurs. Would it cause minor damage, serious injury, or significant property loss? Combining these 3 factors allows arborists to evaluate overall risk. Now let's talk about how risk assessment is performed. It typically begins with a visual inspection. Arborists examine the tree from the ground, looking for signs of defects. They assess the condition of the trunk, branches, and root zone. They also consider site conditions, for example, soil conditions, recent construction activity, and exposure to wind. In some cases, more advanced assessment tools may be used. These may include sounding tools to detect internal decay or specialized equipment to measure wood strength. However, most risk assessments rely heavily on visual evaluation and professional judgment. It's also important to recognize that trees are dynamic living systems. Conditions change over time. A tree that is stable today may become unstable after a storm or construction disturbance. This is why regular inspections are important. Now let's talk about risk management. Once a risk is identified, arborists must decide how to address it. There are several options. Pruning can reduce risk by removing dead wood or reducing load on weak branches. Cabling or bracing can provide structural support. Changing site conditions, such as restricting access beneath a tree, can reduce the likelihood of impact. And in some cases, tree removal may be necessary. The goal is not to eliminate all risk. That is not possible. The goal is to reduce risk to an acceptable level. This concept is important. Risk tolerance varies depending on the situation. A tree in a playground may require a higher level of safety than a tree in a low-use natural area. Urban foresters must consider both biological and social factors when making decisions. For the ISA Urban Forest Professional Exam, focus on the components of tree risk. You should understand the difference between likelihood of failure, likelihood of impact, and consequences. How defects influence risk, the role of targets in determining risk level, and the basic management options available. Questions may ask you to evaluate scenarios and determine appropriate responses. Tree risk assessment is about informed decision-making. It requires observation, experience, and an understanding of both tree biology and human use of space. In the next podcast, we'll build on this by exploring how pests and diseases affect urban trees, and how arborists diagnose and manage these challenges. In the previous podcast, we discussed tree risk assessment and how arborists evaluate the likelihood of failure and potential consequences. Today, we're going to focus on another major challenge in arboriculture: tree pests and diseases. Because even structurally sound trees can decline or fail if they are affected by insects or pathogens. Understanding how to identify and manage these issues is a critical skill. Let's start with an important concept. Not all insects or organisms associated with trees are harmful. In fact, many are beneficial or neutral. The goal is not to eliminate all pests. The goal is to recognize when a problem is significant enough to require management. Tree pests generally fall into a few categories. Defoliators feed on leaves. Examples include caterpillars and beetles that consume foliage. While defoliation can stress a tree, many healthy trees can tolerate occasional leaf loss. However, repeated defoliation can weaken the tree over time. Borers are another important group. These insects tunnel into the wood of the tree. They often target stressed or weakened trees. Examples include emerald ash borer and bronze birch borer. Borers can disrupt the tree's ability to transport water and nutrients, leading to decline and death. Sap-feeding insects, such as aphids and scale insects, feed on plant fluids. These pests can weaken trees and may produce honeydew, which can lead to sooty mold. Now let's turn to diseases. Tree diseases are typically caused by fungi, bacteria, or viruses. Fungal diseases are the most common. They can cause leaf spots, cankers, root rot, and decay. Cankers are areas of dead tissue on branches or trunks. They can disrupt nutrient flow and weaken structural integrity. Root diseases affect the root system and can reduce stability and water uptake. Some diseases spread quickly under favorable conditions. Others develop slowly over time. Now let's talk about diagnosis. Correct diagnosis is essential. Symptoms may include discolored leaves, premature leaf drop, dieback, or unusual growth patterns. However, symptoms alone are not always enough to identify the cause. Different problems can produce similar symptoms. For example, drought stress and root damage may look similar to certain diseases. This is why arborists consider the full context. They evaluate the tree's environment, history, and overall condition. Now let's look at management strategies. One of the most important principles is maintaining overall tree health. Healthy trees are more resistant to pests and diseases. Proper watering, soil management, and pruning all support tree health. Another approach is Integrated Pest Management, or IPM. IPM is a strategy that combines multiple methods to manage pests effectively and responsibly. It includes monitoring pest populations, identifying thresholds for action, and selecting appropriate control methods. Control methods may include cultural practices, biological controls, and, when necessary, chemical treatments. Cultural practices involve improving growing conditions. Biological controls use natural predators or organisms to reduce pest populations. Chemical treatments may be used in specific situations, but they must be applied carefully. Timing is critical. Treatments are often most effective when applied at specific stages in the pest's life cycle. Now let's connect this to urban forestry. Pest and disease outbreaks can affect large portions of the urban forest. This is why species diversity is so important. A diverse urban forest is less likely to experience widespread loss from a single pest or disease. For the ISA Urban Forest Professional Exam, focus on basic pest and disease concepts. You should understand the difference between defoliators, borers, and sap-feeding insects, common types of tree diseases, the importance of proper diagnoses, and the principles of integrated pest management. Questions may involve identifying symptoms and selecting appropriate management strategies. Pests and diseases are a natural part of tree ecosystems, but in urban environments, they can have significant impacts. Understanding how to identify and manage these issues helps protect the health and longevity of the urban forest. In the next podcast, we'll continue with tree health by looking at plant healthcare programs and how arborists take a proactive approach to maintaining tree vitality over time. In the previous podcast, we explored tree pests and diseases and how arborists identify and manage these challenges. Today, we're going to step back and look at a broader, more proactive approach, plant healthcare, often referred to as PHC, because instead of reacting to problems after they appear, arboriculture is increasingly focused on preventing problems before they start. Plant healthcare is a comprehensive, proactive strategy for maintaining tree health over time. It combines monitoring, prevention, and targeted treatments to support tree vitality. The goal is not just to fix issues. The goal is to maintain conditions that allow trees to thrive. Let's start with the core idea. Healthy trees are more resilient. They are better able to resist pests, tolerate stress, and recover from damage. So PHC programs focus on supporting overall tree health, rather than relying solely on reactive treatments. A typical PHC program begins with monitoring. Trees are regularly inspected for signs of stress, pests, or disease. This allows arborists to detect problems early, before they become severe. Monitoring may include visual inspections, soil assessments, and tracking environmental conditions. Early detection is one of the most important advantages of PHC. Now let's look at prevention. Preventative care includes practices such as proper watering, mulching, soil improvement, and appropriate pruning. These practices reduce stress and improve tree vigor. For example, maintaining proper soil moisture helps prevent drought stress. Mulching improves soil conditions and supports root health. Pruning removes dead or weak branches and improves structure. All of these practices contribute to overall tree health. Another important component of PHC is Integrated Pest Management, or IPM. As we discussed in the previous podcast, IPM involves monitoring pest populations and applying treatments only when necessary. PHC programs often include targeted treatments based on monitoring data. For example, if a specific pest is known to affect certain species, preventive treatments may be applied at the appropriate time. Timing is critical. Treatments are most effective when applied during specific stages of a pest's life cycle. PHC programs use this knowledge to increase effectiveness while minimizing unnecessary applications. Now let's talk about soil and nutrient management. Healthy soil is the foundation of tree health. PHC programs often include soil testing and improvement strategies. This may involve adding organic matter, aerating compacted soils, or adjusting pH levels. Fertilization may be included when deficiencies are identified. But as we discussed earlier, fertilization should be based on need, not applied routinely without assessment. Another important aspect of PHC is species selection. Choosing the right tree for the right site reduces stress and improves long-term performance. Trees that are well suited to their environment require fewer interventions over time. Now let's connect PHC to urban forestry. In large-scale urban forest management, reactive care can become costly and inefficient. PHC provides a more strategic approach. By focusing on prevention and early intervention, cities can reduce long-term maintenance costs and improve overall forest health. PHC programs also support consistency. Instead of addressing problems one tree at a time, they apply management practices across entire populations. This improves efficiency and outcomes. For the ISA Urban Forest Professional Exam, focus on the principles of plant healthcare. You should understand the difference between proactive and reactive tree care, the role of monitoring and early detection, the importance of prevention through proper cultural practices, and how PHC integrates with pest management strategies. Questions may ask you to identify the benefits of PHC programs and appropriate applications. Plant healthcare represents a shift in how we think about arboriculture. It moves from reaction to prevention, from isolated treatments to integrated management. In the next podcast, we'll continue exploring arboricultural practices by looking at tree removal and how arborists make decisions when trees can no longer be preserved safely. In the previous podcast, we explored plant healthcare and the importance of proactive management to maintain tree health. Today, we're going to focus on one of the most difficult but necessary aspects of arboriculture, tree removal. Because while the goal of urban forestry is to preserve and grow the urban forest, there are situations where removing a tree is the most appropriate decision. Understanding when and why to remove a tree is a critical skill. Tree removal is not just a technical task. It is a decision-making process that balances safety, tree health, site conditions, and long-term management goals. Let's start with the most important factor: risk. One of the primary reasons for tree removal is unacceptable risk. If a tree has a high likelihood of failure and the potential consequences are severe, removal may be necessary. This could include trees with significant structural defects, advanced decay, or compromised root systems. As we discussed in earlier podcasts, risk is a combination of likelihood of failure, likelihood of impact, and severity of consequences. If risk cannot be reduced to an acceptable level through pruning or support systems, removal becomes the appropriate option. Another reason for removal is severe decline. Trees may decline due to disease, pests, environmental stress, or age. If a tree is no longer able to sustain healthy growth and recovery is unlikely, removal may be considered. This is especially true if the tree is located in a high-use area. Now let's talk about site conflicts. Urban trees often grow in close proximity to infrastructure. Roots may damage sidewalks or utilities. Branches may interfere with buildings or power lines. In some cases, these conflicts can be managed through pruning or root management. But in other cases, removal may be necessary. Species selection also plays a role. If a tree was poorly matched to its site, it may create ongoing maintenance issues. For example, a large growing species planted in a small space may eventually outgrow its location. Now let's discuss the decision-making process. Tree removal decisions should be based on assessment and professional judgment. Arborists evaluate the condition of the tree, the site, and the surrounding environment. They consider alternative options, such as pruning, cabling, or site modification. Removal is typically considered when other options are not sufficient. It's also important to consider the value of the tree. Mature trees provide significant environmental and social benefits. Removing a large tree represents a loss of canopy, shade, and ecosystem services. This is why removal decisions should not be taken lightly. Whenever possible, preservation is preferred. However, safety must always be the priority. Now let's talk about the process of removal. Tree removal involves specialized equipment and trained professionals. It may include climbing, rigging, or the use of aerial lifts. Safety is critical. Improper removal techniques can result in injury or property damage. After removal, the site should be evaluated for replanting. Urban forestry is not just about removal. It is about maintaining canopy over time. When a tree is removed, there is often an opportunity to plant a new tree. This helps maintain long-term canopy continuity. Now let's connect this to urban forest management. Removal is part of the life cycle of the urban forest. Trees are planted, grow, mature, and eventually decline. Managing this cycle requires planning. Cities must balance removal with planting to maintain canopy levels. For the ISA Urban Forest Professional Exam, focus on decision-making in tree removal. You should understand the role of risk in removal decisions, the difference between decline and structural failure, the importance of site conflicts and species selection, and the need to consider alternatives before removal. Questions may involve evaluating scenarios and determining when removal is appropriate. Tree removal is one of the most challenging decisions in arboriculture. It requires balancing safety, preservation, and long-term planning. In the next podcast, we'll continue by looking at tree preservation strategies and how arborists work to extend the life of trees whenever possible. In the previous podcast, we discussed tree removal and how arborists make decisions when a tree can no longer be safely maintained. Today, we're going to focus on the other side of that decision: tree preservation. Because while removal is sometimes necessary, the primary goal of arboriculture is to keep trees healthy, stable, and functional for as long as possible. Tree preservation is about extending the life of trees. It involves a combination of practices designed to reduce stress, improve structure, and support long-term health. Let's start with an important concept. Preservation is most effective when it is proactive. Waiting until a tree is already in severe decline limits the available options. Early intervention provides the best chance for success. One of the most common preservation strategies is pruning. As we discussed earlier, pruning can improve structure, reduce risk, and remove dead or damaged branches. In preservation, pruning is often used to reduce stress on weakened areas of the tree. For example, reducing the weight of long branches can decrease the likelihood of failure. Another key strategy is soil management. Healthy soil supports healthy roots. Improving soil conditions through aeration, mulching, and the addition of organic matter can significantly improve tree health. This is especially important in urban environments where soils are often compacted or disturbed. Irrigation is another important factor. Trees under water stress are more vulnerable to pests, disease, and decline. Providing supplemental water during dry periods can improve tree vitality. This is particularly important for mature trees that have experienced root loss or site changes. Now let's talk about root protection. Roots are often damaged by construction, grading, or soil compaction. Protecting the root zone is critical for preserving tree health. This includes establishing protection zones, limiting soil disturbance, and avoiding unnecessary excavation. Support systems, such as cabling and bracing, may also be used as part of preservation. These systems help stabilize trees with structural weaknesses and reduce the likelihood of failure. They are often used for high-value trees, where removal is not desirable. Another important concept is stress reduction. Urban trees are exposed to many stress factors. These include limited rooting space, heat, pollution, and mechanical damage. Preservation strategies aim to reduce these stresses wherever possible. This may involve improving site conditions, adjusting irrigation, or modifying surrounding land use. Now let's consider pest and disease management. As we discussed in earlier podcasts, healthy trees are more resistant to pests and diseases. However, when problems occur, timely intervention is important. This may include targeted treatments, pruning of affected areas, or changes in management practices. Tree preservation also involves monitoring. Trees should be inspected regularly to identify changes in condition. Early detection of problems allows for more effective intervention. Monitoring is especially important for trees that have known defects or have experienced stress. Now let's connect this to urban forest management. Preserving existing trees is often more valuable than planting new ones. Mature trees provide greater ecosystem services than young trees. They offer more shade, more cooling, and more environmental benefits. Losing a mature tree can take decades to replace. This is why preservation is a key priority. For the ISA Urban Forest Professional Exam, focus on preservation strategies. You should understand the importance of proactive management, the role of pruning in preservation, how soil and water management support tree health, the importance of root protection, and how monitoring supports long-term care. Questions may involve selecting appropriate strategies to preserve trees under stress. Tree preservation is about maintaining value. It's about recognizing that every mature tree represents years of growth and environmental benefit. And it's about making decisions that extend that value into the future. In the next podcast, we'll continue exploring arboricultural practices by looking at tree selection and nursery stock, and how choosing the right tree at the beginning influences everything that follows. In the previous podcast, we explored tree preservation strategies and how arborists work to extend the life of existing trees. Today, we're going to shift back to the beginning of the tree life cycle, tree selection. Because one of the most important decisions in arboriculture happens before a tree is ever planted, choosing the right tree. Tree selection has long-term consequences. A well-chosen tree can thrive for decades with minimal intervention. A poorly chosen tree can struggle, create conflicts, and require constant maintenance. So today we're going to focus on how arborists make informed decisions when selecting trees for urban environments. Let's start with the most important principle: right tree, right place. This concept is fundamental in both arboriculture and urban forestry. It means selecting a tree species that is well suited to the specific conditions of the planting site. To do this, arborists evaluate several factors. First, site conditions. This includes available space both above and below ground. Some trees grow large and require significant canopy and root space. Others are more compact and suitable for restricted areas. Soil conditions are also critical. Is the soil compacted? Is drainage adequate? What is the soil pH? These factors influence which species will perform well. Next, consider environmental conditions. Sunlight availability, temperature extremes, and exposure to wind all affect tree performance. Urban environments often create challenging conditions, including reflected heat from pavement and buildings. Species must be able to tolerate these stresses. Now let's talk about infrastructure conflicts. Trees must coexist with roads, sidewalks, utilities, and buildings. Large trees planted in small spaces may damage sidewalks or interfere with overhead lines. Selecting species with appropriate growth habits helps reduce these conflicts. Another important factor is species diversity. As we discussed earlier, urban forests should avoid over-reliance on a single species. Selecting a variety of species helps reduce the risk of widespread loss due to pests or diseases. Now let's shift to nursery stock. Once a species is selected, the next step is choosing a high-quality tree. Not all nursery trees are the same. Tree quality at the time of planting has a significant impact on long-term success. There are several types of nursery stock. Container-grown trees are grown in pots. Balled and burlap trees are grown in the ground and then harvested with a soil ball wrapped in burlap. Bare root trees are harvested without soil around the roots. Each type has advantages and considerations. Now let's focus on quality. One of the most important things to look for is root structure. Roots should be well distributed and not circling within the container. Circling roots can lead to long-term structural problems. The root flare should be visible. If it is buried, the tree may have been planted too deeply in the nursery. Trunk structure is also important. The tree should have a single dominant leader, unless the species naturally has multiple stems. Branches should be well spaced. Avoid trees with large wounds, cracks, or signs of stress. Another consideration is tree size. Larger trees may seem more appealing, but they often experience more transplant stress. Smaller trees typically establish faster and may outperform larger trees over time. Now let's connect this to long-term outcomes. Tree selection and nursery stock quality influence everything that follows. A well-selected and properly grown tree requires less maintenance, experiences fewer problems, and provides greater long-term benefits. For the ISA Urban Forest Professional Exam, focus on the principles of tree selection. You should understand the concept of right tree, right place, the importance of site conditions, how species selection affects long-term performance, and how to evaluate nursery stock quality. Questions may involve identifying appropriate species or recognizing poor quality planting material. Tree selection is where arboriculture begins. It sets the stage for everything that follows. Choosing the right tree and choosing a healthy tree are two of the most important decisions an arborist can make. In the next podcast, we'll continue with planting success by looking at transplanting and how trees are moved and established in new environments. In the previous podcast, we discussed tree selection and nursery stock and how choosing the right tree is critical for long-term success. Today, we're going to focus on what happens next. Transplanting. Because selecting a good tree is only the first step. Successfully moving that tree from the nursery to the landscape and helping it establish is what determines whether it survives and thrives. Transplanting is the process of relocating a tree from one location to another. This may involve moving trees from a nursery to a planting site, or in some cases, relocating existing trees within a landscape. Regardless of the situation, transplanting creates stress, and understanding that stress is key to managing it. Let's start with what happens during transplanting. When a tree is dug from a nursery, a large portion of its root system is left behind. Only a portion of the roots are included in the root ball. This means the tree loses a significant amount of its ability to absorb water and nutrients. At the same time, the canopy remains largely intact. This creates an imbalance. The tree has more leaves than the reduced root system can support. This is known as transplant shock. Symptoms of transplant shock may include reduced growth, leaf drop, or dieback. In some cases, the tree may survive but takes several years to fully establish. So how do arborists manage transplant shock? It starts with proper handling. Trees should be handled carefully during transport and planting. The root ball should be protected from damage and drying out. Dropping or breaking the root ball can severely impact survival. Next is proper planting, which we discussed in podcast 31. Correct planting depth, proper mulching, and appropriate watering are all essential. But transplanting also involves timing. The best time to transplant most trees is during the dormant season. This reduces stress because the tree is not actively growing. In many climates, this means late fall or early spring. However, timing may vary depending on species and regional conditions. Now let's talk about root-to-shoot balance. Because the root system is reduced during transplanting, the tree may not be able to support its full canopy. In some cases, light pruning may be used to reduce stress. However, excessive pruning should be avoided. Leaves are needed for photosynthesis, which provides energy for root growth. The focus should be on supporting root recovery, rather than reducing canopy excessively. Water management is one of the most important factors in transplant success. Newly transplanted trees require consistent watering. The goal is to maintain adequate soil moisture without overwatering. Too little water leads to drought stress. Too much water reduces oxygen in the soil. Both can harm the tree. Mulching also plays a key role. Mulch helps retain moisture, regulate soil temperature, and reduce competition from grass. As we discussed earlier, mulch should be applied properly and not piled against the trunk. Now let's consider the establishment period. Tree establishment refers to the time it takes for a tree to recover from transplanting and develop a functional root system. A general guideline is that a tree requires 1 year of establishment for every inch of trunk diameter. For example, a 2-inch tree may take approximately 2 years to establish. During this time, the tree is more vulnerable to stress. Monitoring is essential. Arborists should regularly check for signs of stress, pests, or poor growth. Early intervention can improve outcomes. Now let's connect transplanting to urban forestry. Successful establishment is critical for long-term canopy development. If newly planted trees fail, canopy goals cannot be achieved. This is why proper planting and aftercare are so important. For the ISA Urban Forest Professional Exam, focus on transplanting concepts. You should understand the concept of transplant shock, the importance of root loss during transplanting, proper timing for transplanting, the role of watering and mulching, and the establishment period. Questions may involve identifying factors that influence transplant success. Transplanting is a critical transition in a tree's life. It is the point where a tree must adapt to a new environment and rebuild its root system. With proper care, that transition can lead to long-term success. In the next podcast, we'll continue exploring arboricultural practices by looking at root management and how arborists handle root conflicts and root-related issues in urban environments. In the previous podcast, we discussed transplanting and how trees establish after being moved into a new environment. Today, we're going to focus on one of the most challenging aspects of arboriculture in urban settings: root management. Because while roots are essential for tree health and stability, they are also the source of many conflicts in cities. Most of what we see of a tree is above ground, but most of what determines its survival is happening below ground. Roots anchor the tree, absorb water and nutrients, and store energy. At the same time, roots grow in search of space, water, and oxygen. And in urban environments, that often puts them in conflict with infrastructure. Let's start with a key concept: root distribution. Tree roots are not deep, taproot systems, like many people assume. Most roots are located in the top 12 to 18 inches of soil. They spread outward, often extending well beyond the canopy. This wide, shallow root system makes trees very effective at absorbing surface water. But it also increases the likelihood of conflicts with sidewalks, curbs, and underground utilities. Now let's talk about common root conflicts. One of the most familiar issues is sidewalk lifting. As roots grow and increase in diameter, they can push up pavement. This creates uneven surfaces and potential safety hazards. Another issue is root intrusion into utilities. Roots may enter pipes or other underground systems, especially if there are existing cracks or leaks. Roots are not actively seeking out pipes. They are following moisture, but the result can still be significant damage. Root conflicts also occur in limited soil volumes. When trees are planted in small planting pits or narrow strips, roots have limited space to expand. This can lead to poor tree growth and increased infrastructure pressure. So how do arborists manage these conflicts? Let's start with prevention. The best way to manage root conflicts is to prevent them through proper planning. This includes selecting appropriate species for the site. Some species have more aggressive root systems than others. Planting large trees in small spaces often leads to long-term problems. Providing adequate soil volume is critical. Larger soil volumes allow roots to grow without causing damage. This improves both tree health and infrastructure performance. Now let's look at root pruning. In some cases, roots may be cut to address conflicts. However, root pruning must be done carefully. Removing large roots can reduce stability and increase the risk of tree failure. It can also reduce the tree's ability to absorb water and nutrients. Root pruning should be done selectively and with an understanding of the tree's structure. Another approach is the use of root barriers. Root barriers are physical barriers installed in the soil to redirect root growth. They are often used near sidewalks or foundations. Barriers guide roots downward or away from infrastructure. However, they must be installed properly to be effective. Now let's talk about advanced solutions. In some urban environments, engineered systems are used to support both trees and infrastructure. Structural soils and suspended pavement systems provide space for root growth while supporting surface loads. These systems help reduce conflicts and improve tree performance. It's also important to consider long-term management. Once a conflict develops, solutions may include repairing infrastructure, modifying the site, or in some cases, removing the tree. Each situation requires careful evaluation. Now let's connect this to urban forestry. Root management is a balance. It involves protecting tree health while maintaining safe and functional infrastructure. Decisions must consider both biological and engineering factors. For the ISA Urban Forest Professional Exam, focus on root behavior and management. You should understand the shallow and spreading nature of root systems, common root-related conflicts, the risks associated with root pruning, the use of root barriers, and the importance of adequate soil volume. Questions may involve selecting appropriate solutions to root-related problems. Roots are the hidden foundation of the urban forest. They support tree health, stability, and growth. But in cities, they also create challenges. Understanding how roots grow and how to manage them is essential for successful arboriculture. In the next podcast, we'll continue with tree care practices by exploring tree protection and maintenance around utilities, and how arborists manage trees near power lines and other critical infrastructure. In the previous podcast, we explored root management and how underground conflicts affect both trees and infrastructure. Today, we're moving above ground to one of the most visible and often controversial areas of arboriculture: tree maintenance around utilities. Because in urban environments, trees and utilities must share the same space, and that creates challenges, especially when it comes to overhead power lines, Trees growing near power lines require regular maintenance to prevent interference. If branches contact electrical lines, they can cause power outages, equipment damage, or even fires. This makes vegetation management around utilities a critical public safety issue. Let's start with a key concept. Clearance. Utility pruning is primarily about maintaining safe distances between tree branches and power lines. This is often referred to as line clearance. The amount of clearance required depends on the type of line, voltage, and local regulations. Utility arborists are trained to maintain these clearances while minimizing impact on tree health. Now let's talk about pruning methods. Utility pruning often uses a technique called directional pruning. Directional pruning involves removing or reducing branches in a way that guides future growth away from power lines. Instead of simply cutting back branches to a fixed distance, arborists make cuts that encourage growth in a safer direction. This helps reduce the frequency of future pruning. However, utility pruning can sometimes result in trees with unusual shapes. For example, trees growing under power lines may develop a V shape or uneven canopy. This is a result of repeated pruning to maintain clearance. While this may not be aesthetically ideal, it is necessary for safety. Now let's consider species selection. One of the best ways to reduce conflicts with utilities is through proper tree selection. Planting smaller growing species under power lines reduces the need for frequent pruning. Larger species can be planted in areas where they have adequate space to grow without interfering with utilities. This approach is often referred to as the right tree, right place principle. Planning ahead reduces long-term maintenance costs and improves tree health. Now let's talk about underground utilities. Trees also interact with buried infrastructure such as water lines, sewer pipes, and communication cables. As we discussed in the previous podcast, roots can grow toward sources of moisture. If pipes have leaks or weak points, roots may enter and cause blockages. Proper installation and maintenance of utilities can reduce these risks. Root barriers and appropriate species selection can also help manage conflicts. Now let's look at safety. Working around utilities requires specialized training. Utility arborists must understand electrical hazards and follow strict safety protocols. Only qualified personnel should perform pruning near energized lines. This is not typical tree work. It requires additional expertise and equipment. Now let's connect this to urban forestry. Utility conflicts are one of the most common reasons for tree pruning in cities. Balancing safety, infrastructure needs, and tree health is a constant challenge. Good planning, proper species selection, and skilled pruning can reduce these conflicts. For the ISA Urban Forest Professional Exam, focus on utility-related tree management. You should understand the purpose of line clearance pruning, the concept of directional pruning, the importance of species selection near utilities, and the safety considerations when working around power lines. Questions may involve identifying appropriate pruning practices or management strategies near utilities. Trees and utilities must coexist in urban environments. Managing that relationship requires careful planning and skilled arboriculture. When done correctly, it protects both public safety and the long-term health of the urban forest. In the next podcast, we'll shift to another important aspect of arboriculture: tree inspection and monitoring, and how arborists track tree condition over time. In the previous podcast, we discussed how arborists manage trees around utilities and balance safety with tree health. Today we're going to focus on a practice that connects everything we've covered so far: tree inspection and monitoring. Because arboriculture is not just about performing tasks like pruning or planting. It's about continuously observing trees and making informed decisions over time. Tree inspection is the process of evaluating a tree's condition. Monitoring is the ongoing process of tracking changes in that condition. Together, they form the foundation of effective tree management. Let's start with inspection. A tree inspection typically begins with a visual assessment. Arborists look at the entire tree, from the roots to the crown. They examine the trunk, branches, leaves, and surrounding site conditions. They are looking for signs of stress, defects, pests, disease, and structural issues. At the root level, arborists may look for exposed roots, soil disturbance, or signs of decay. At the trunk, they look for cracks, cavities, or areas of decay. In the canopy, they assess leaf condition, branch structure, and the presence of deadwood. Inspection is not just about identifying problems. It is also about understanding overall tree condition. Is the tree growing normally? Is it showing signs of decline? Is it adapting well to its environment? Now let's talk about monitoring. Monitoring involves repeating inspections over time. Trees are living organisms. Their condition changes. A tree that appears healthy today may develop issues in the future. Regular monitoring allows arborists to detect changes early. For example, a small crack observed during one inspection may expand over time. Early detection allows for timely intervention. Monitoring also helps evaluate the effectiveness of management practices. If a tree has been pruned, treated, or protected, Follow-up inspections can determine whether those actions were successful. Now let's look at inspection frequency. Not all trees require the same level of monitoring. High-risk trees, such as those near buildings or high-use areas, may require more frequent inspections. Trees with known defects or health issues should also be monitored closely. Lower-risk trees in less used areas may require less frequent evaluation. Now let's talk about documentation. Inspection findings should be recorded. This may include written notes, photographs, or digital records. Documentation helps track changes over time and supports decision-making. It also provides a record of management actions. Now let's consider tools and technology. While visual inspection is the most common method, additional tools may be used. These can include sounding tools to detect internal decay or advanced equipment to assess structural integrity. GIS systems may be used to track inspection data across large tree populations. Now let's connect this to risk management. Tree inspection is closely tied to tree risk assessment. Identifying defects early allows arborists to reduce risk through pruning, support systems, or other interventions. Monitoring ensures that risks are managed over time. Now let's connect this to urban forestry. Cities often manage thousands or even millions of trees. Inspection and monitoring programs help prioritize maintenance and allocate resources efficiently. They allow urban foresters to move from reactive management to proactive planning. For the ISA Urban Forest Professional Exam, focus on inspection principles. You should understand what arborists look for during inspections, the importance of monitoring over time, how inspection frequency relates to risk, and the role of documentation. Questions may involve identifying signs of tree problems or selecting appropriate inspection strategies. Tree inspection and monitoring are about awareness. They allow arborists to understand how trees are changing and to respond before problems become severe. In the next podcast, we'll continue with arboricultural practices by looking at tree inventories and data management, and how inspection data is used to guide large-scale urban forest decisions. In the previous podcast, we discussed tree inspection and monitoring, and how arborists track tree condition over time. Today, we're going to expand that idea from individual trees to entire populations, tree inventories, and data management. Because while inspecting individual trees is important, urban forestry requires managing thousands or even millions of trees. And that requires data. A tree inventory is a structured system for collecting and organizing information about trees within a defined area. It is one of the most important tools in arboriculture and urban forest management. Let's start with what a tree inventory includes. At a basic level, an inventory records information about each tree. This may include species location diameter at breast height, or DBH condition maintenance needs, and sometimes risk ratings. More advanced inventories may include additional data such as tree height, canopy spread, site conditions, and past maintenance history. Each tree becomes a data point. Now let's talk about why this matters. Without an inventory, tree management is reactive. Work is done in response to complaints or visible problems. With an inventory, management becomes proactive. Arborists can plan maintenance cycles, identify patterns, and allocate resources more efficiently. For example, an inventory can help identify how many trees require pruning. It can show which areas have a high concentration of declining trees. It can reveal imbalances in species diversity. This information supports better decision-making. Now let's look at different types of inventories. A complete inventory includes every tree within a defined area. This provides the most detailed information, but it requires significant time and resources. A sample inventory collects data from a subset of trees and uses that information to estimate conditions across a larger area. This approach is faster, but less precise. Windshield surveys, which we discussed earlier, provide even broader assessments but with limited detail. Each method has its place depending on goals and resources. Now let's talk about technology. Modern tree inventories are often managed using digital systems. Trees are mapped using GPS and stored in GIS databases. This allows arborists to visualize tree locations and analyze spatial patterns. GIS-based inventories are especially powerful. They allow users to overlay tree data with other information such as land use, population density, or infrastructure. This helps identify areas with low canopy, high maintenance needs, or increased risk. Now let's consider how inventory data is used. One of the primary uses is maintenance planning. Cities often operate on pruning cycles. For example, a city may aim to prune all street trees every 5 to 7 years. Inventory data helps track which trees have been pruned and which are due. Inventories also support risk management. Trees with higher risk ratings can be prioritized for inspection or maintenance. Another important use is budgeting. Tree care requires funding. Inventories help estimate the cost of maintenance, planting, and removal. They provide data that supports funding requests and policy decisions. Now let's connect this to long-term planning. Inventory data helps cities plan for the future. It can reveal trends in tree age, species composition, and health. This allows urban foresters to develop strategies for planting, preservation, and risk reduction. For the ISA Urban Forest Professional exam, focus on how inventories support management. You should understand what data is included in a tree inventory, the difference between complete and sample inventories, the role of GIS in managing tree data, and how inventories support planning, maintenance, and budgeting. Questions may involve identifying how data is used to guide decisions. Tree inventories turn observations into information. They allow arborists to move beyond individual trees and manage entire populations. They provide the foundation for informed, efficient, and proactive urban forest management. In the previous podcast, we explored tree inventories and how data supports large-scale tree management. Today, we're going to build on that by looking at how arborists turn that data into action. Work planning and maintenance cycles. Because collecting data is only useful if it leads to organized, effective management. Urban forestry is not just about knowing what needs to be done. It's about deciding when, where, and how to do it. And that requires planning. Let's start with a key concept: maintenance cycles. A maintenance cycle is a planned schedule for performing routine tree care activities. One of the most common examples is pruning cycles. Cities often aim to prune all public trees within a set period of time. For example, a 5-year pruning cycle means that every tree is pruned once every 5 years. This approach ensures that trees are maintained regularly, rather than only when problems arise. Maintenance cycles support proactive management. Instead of responding to emergencies, arborists can address issues before they become severe. Now let's talk about how these cycles are developed. This is where inventory data becomes essential. Inventory data shows when trees were last serviced and what condition they are in. This allows arborists to prioritize work. For example, trees in poor condition may be scheduled for more frequent inspections or maintenance. Trees in high-use areas may also be prioritized. Now let's consider different types of work. Not all tree care activities fit neatly into cycles. Routine maintenance includes activities such as pruning, inspection, and young tree care. These tasks are often scheduled in cycles. Reactive work includes responding to storms, emergency removals, or public complaints. This work is unpredictable and must be addressed as needed. Effective work planning balances both types. Now let's look at prioritization. When resources are limited, arborists must decide which work to perform first. Several factors influence prioritization. Risk is one of the most important. Trees that pose a higher risk to people or property are addressed first. Location is another factor. Trees in high-traffic areas may receive higher priority. Tree condition also plays a role. Trees in poor health may require immediate attention. Now let's talk about efficiency. Work planning is not just about deciding what to do. It's also about organizing how work is completed. Grouping tasks by location can reduce travel time. Scheduling similar types of work together can improve efficiency. Using data and mapping tools helps optimize routes and resource allocation. Now let's consider staffing and resources. Urban forestry programs must match their workload with available staff and budget. This includes arborists, equipment, and contractors. Work planning helps ensure that resources are used effectively. It also helps justify funding by demonstrating workload and needs. Now let's connect this to long-term management. Maintenance cycles support consistency. They ensure that all trees receive care over time. This helps maintain tree health, reduce risk, and extend tree lifespan. Without cycles, some trees may be neglected, while others receive repeated attention. Now let's connect this to urban forestry goals. Work planning helps cities achieve canopy goals, manage risk, and maintain tree populations. It turns strategy into action. For the ISA Urban Forest Professional exam, focus on planning concepts. You should understand the purpose of maintenance cycles, the difference between proactive and reactive work, how inventory data supports planning, and how prioritization is determined. Questions may involve selecting appropriate planning strategies or identifying efficient work practices. Work planning is what makes arboriculture operational. It connects data, decisions, and action. It ensures that tree care is not random, but organized and effective. In the next podcast, we'll continue by exploring safety practices in arboriculture and how arborists protect themselves and others while performing tree work. In the previous podcast, we discussed work planning and maintenance cycles and how arborists organize and prioritize tree care operations. Today, we're going to focus on something that underlies every arboricultural activity: safety. Because arboriculture is a physically demanding and potentially hazardous profession. Working with trees often involves heights, heavy equipment, sharp tools, and unpredictable conditions. So maintaining safety is not optional. It is essential. Let's start with a basic principle. Every task in arboriculture should be approached with a safety mindset. Before any work begins, arborists assess the site. They look for hazards such as unstable trees, overhead utilities, uneven ground, and nearby traffic. This is often referred to as a job hazard assessment. Identifying risks before work begins helps prevent accidents. Now let's talk about personal protective equipment, or PPE. PPE is designed to protect workers from injury. Common PPE in arboriculture includes helmets to protect against falling objects, eye protection to guard against debris, hearing protection when using equipment, gloves for handling tools and materials, chainsaw-resistant chaps or pants, and appropriate footwear for stability and protection. Using PPE correctly is one of the simplest and most effective ways to reduce injury. Now let's consider working at height. Tree work often involves climbing or using aerial lifts. Climbing requires specialized training and equipment. This includes ropes, harnesses, and climbing systems designed for safety and control. Aerial lifts provide another method for accessing the canopy. Operators must be trained to use lifts safely and understand load limits and positioning. Fall protection is critical in both cases. Now let's talk about equipment safety. Chainsaws, chippers, and other equipment are powerful tools. They must be used properly. Chainsaw safety includes maintaining sharp chains, using proper cutting techniques, and understanding kickback risks. Chippers require careful operation to prevent entanglement or injury. Equipment should be inspected regularly to ensure it is in safe working condition. Now let's consider electrical hazards. As we discussed in podcast 45, trees near power lines present serious risks. Contact with energized lines can result in severe injury or death. Only trained and qualified personnel should work near electrical utilities. Maintaining safe distances is essential. Now let's talk about communication. Tree work often involves teams. Clear communication between crew members is critical. This includes using signals, verbal communication, and maintaining awareness of each other's positions. Miscommunication can lead to accidents. Now let's consider environmental conditions. Weather plays a significant role in safety. High winds, rain, ice, or extreme heat can increase risks. Arborists must evaluate conditions and adjust work accordingly. Sometimes, the safest decision is to delay work. Now let's connect safety to professionalism. Safety is not just about avoiding accidents. It reflects the professionalism of arborists. Safe practices protect workers, clients, and the public. They also build trust and credibility. Now let's connect this to urban forestry. Cities rely on arborists to manage trees safely. Unsafe practices can result in injuries, property damage, and liability. This is why safety standards and training are essential. For the ISA Urban Forest Professional Exam, focus on safety principles. You should understand the importance of job hazard assessments, the role of PPE basic climbing and equipment safety concepts, and the risks associated with electrical hazards. Questions may involve identifying safe work practices or recognizing hazardous situations. Safety is the foundation of arboriculture. Every task, from pruning to removal, depends on safe practices. Without safety, nothing else matters. In the next podcast, we'll continue exploring arboricultural practices by looking at equipment and tools, and how arborists use specialized tools to perform tree care effectively and safely. In the previous podcast, we focused on safety practices and how arborists protect themselves, their crews, and the public. Today, we're going to look at the tools that make arboriculture possible. Arboricultural equipment, because tree care is not just about knowledge. It's also about using the right tools for the job and using them correctly. Arborists rely on a wide range of equipment to perform tasks such as pruning, planting, removal, and maintenance. Each tool has a specific purpose, and choosing the right tool improves both efficiency and safety. Let's start with basic hand tools. These include pruning shears, loppers, and handsaws. Pruning shears are used for small branches. Loppers are used for medium-sized branches. Handsaws are used for larger cuts where more control is needed. These tools allow arborists to make precise cuts, which is important for tree health. Now let's move to power tools. Chainsaws are one of the most commonly used tools in arboriculture. They are used for cutting larger branches and removing trees. Chainsaws must be used with care. Proper handling, maintenance, and safety awareness are essential. Pole saws are another important tool. They allow arborists to reach higher branches from the ground. This reduces the need for climbing in some situations. Now let's talk about climbing equipment. When working in the canopy, arborists use ropes, harnesses, and climbing systems. These systems allow arborists to move safely within the tree. Climbing techniques require training and practice. They must be performed using proper safety protocols. Aerial lifts are another option for accessing trees. These machines allow arborists to work at height without climbing. They are especially useful in urban environments where space allows for equipment access. Now let's consider rigging equipment. Rigging is used during pruning and removal to control the movement of branches and tree sections. Ropes, pulleys, and lowering devices are used to guide falling materials safely to the ground. This is especially important in urban areas, where space is limited and targets are present. Now let's talk about chippers. Chippers are used to process branches and wood into smaller pieces. This helps manage debris and allows for easier disposal or reuse. Chippers must be operated carefully. Improper use can result in serious injury. Now let's consider stump grinders. After a tree is removed, the stump may remain. Stump grinders are used to remove the stump and allow for replanting or site restoration. Now let's talk about maintenance. Tools must be maintained regularly. Sharp tools make cleaner cuts, which are better for tree health. Dull tools can damage tissue and increase the risk of disease. Equipment should be inspected to ensure it is functioning properly. Now let's connect tool use to arboricultural principles. Using the right tool is not just about convenience. It affects the quality of work. For example, making a clean pruning cut supports proper compartmentalization. Using improper tools can lead to poor cuts and increased decay. Now let's connect this to urban forestry. Efficient use of tools allows arborists to manage large tree populations effectively. It also supports safety and reduces the risk of accidents. For the ISA Urban Forest Professional Exam, focus on tool selection and use. You should understand the purpose of different pruning tools, basic chainsaw and equipment, safety concepts, the role of climbing and rigging equipment, and the importance of tool maintenance. Questions may involve selecting appropriate tools for specific tasks. Tools are an extension of the arborist's knowledge and skill. Used correctly, they allow arborists to care for trees efficiently and safely. In the next podcast, we'll continue with arboricultural practices by exploring tree care standards and how industry guidelines ensure consistent and professional tree management. In the previous podcast, we discussed arboricultural tools and equipment and how they are used to perform tree care safely and effectively. Today, we're going to focus on something that guides how all of that work is done: tree care standards. Because arboriculture is not just based on experience or individual judgment, it is supported by established industry standards and best practices. These standards help ensure that tree care is performed consistently, safely, and effectively. Let's start with one of the most important frameworks in arboriculture, the ANSI A300 standards. ANSI stands for the American National Standards Institute. The ANSI A300 standards provide guidelines for professional tree care operations. They cover a wide range of practices, including pruning, soil management, tree support systems, and tree risk assessment. These standards define what should be done in professional tree care. For example, ANSI A300 standards outline proper pruning practices. They describe how cuts should be made, how much canopy should be removed, and what objectives pruning should achieve. They also emphasize the importance of preserving the branch collar and avoiding improper cuts. Now let's talk about best management practices, or BMPs. BMPs are developed by organizations such as the International Society of Arboriculture. They provide more detailed guidance on how to perform specific tasks. If ANSI standards describe what should be done, BMPs describe how to do it. For example, BMP manuals may include step-by-step guidance for pruning, tree planting, or risk assessment. They provide practical information that arborists can apply in the field. Now let's consider why standards are important. First, they promote consistency. When arborists follow the same standards, the quality of work becomes more uniform. This is especially important in urban forestry programs, where multiple crews or contractors may be involved. Second, standards support safety. Proper procedures reduce the risk of injury and damage. They ensure that work is performed in a way that protects both workers and the public. Third, standards support tree health. Following proper techniques helps minimize damage and supports long-term tree function. For example, making proper pruning cuts allows the tree to compartmentalize wounds more effectively. Now let's talk about professional responsibility. Arborists are expected to follow accepted standards. This is part of professional practice. It also relates to liability. If work is performed improperly and results in damage or injury, failure to follow standards may be a factor. Now let's connect standards to decision-making. Standards provide a framework, but they do not replace judgment. Every tree and site is different. Arborists must apply standards in a way that considers specific conditions. For example, the appropriate pruning approach may vary depending on species, age, and site conditions. Standards guide decisions, but they do not make decisions. Now let's connect this to urban forestry. Cities often require that tree work performed on public trees follows ANSI standards. This ensures that work is consistent across the program. It also helps maintain public trust. Residents expect that tree care is performed professionally. For the ISA Urban Forest Professional Exam, focus on the role of standards. You should understand what ANSI A300 standards are, the difference between standards and BMPs, why standards are important for consistency and safety, and how standards support tree health. Questions may involve identifying proper practices based on standard guidelines. Tree care standards provide the foundation for professional arboriculture. They ensure that work is performed correctly, safely, and consistently. In the next podcast, we'll continue exploring arboricultural practices by looking at tree protection policies and ordinances, and how regulations shape tree care in urban environments. In the previous podcast, we explored tree care standards and how ANSI guidelines and best management practices shape professional arboriculture. Today, we're going to move from standards to something broader: policies and ordinances. Because in urban environments, tree care is not just guided by best practices. It is also shaped by laws, regulations, and local policies. Tree protection policies and ordinances are tools used by cities to manage and protect their urban forest. They establish rules for how trees are planted, maintained, and removed. And they help ensure that trees are treated as valuable community assets. Let's start with a basic definition. A tree ordinance is a local law that regulates activities involving trees. This may include planting, pruning, removal, and protection during construction. Tree ordinances vary from city to city, but they generally share common goals. These goals include protecting existing canopy, promoting sustainable planting, and reducing unnecessary tree loss. Now let's look at some common elements of tree ordinances. One of the most common is permitting. In many cities, removing certain trees requires a permit. This helps prevent unnecessary or excessive removal. Permits may be required for trees above a certain size or located in specific areas. Another element is tree protection during development. As we discussed in podcast 35, construction can significantly impact trees. Ordinances often require tree protection measures such as fencing, root zone protection, and supervision during construction. These requirements help preserve trees that might otherwise be damaged. Now let's talk about replacement requirements. Some ordinances require that trees removed from a site be replaced. This may involve planting new trees or contributing to a tree fund. The goal is to maintain overall canopy over time. Another important concept is protected trees. Certain trees may receive additional protection based on size, species, or historical significance. For example, large mature trees or heritage trees may be designated as protected. Removing these trees may require special approval. Now let's consider enforcement. Policies are only effective if they are enforced. Cities may conduct inspections, issue fines, or require corrective actions when regulations are not followed. Enforcement helps ensure compliance and maintains the integrity of the program. Now let's talk about planning. Tree policies are often integrated into broader urban planning efforts. They may be included in zoning regulations, development guidelines, or sustainability plans. This helps ensure that trees are considered in land use decisions. Now let's connect this to arboriculture. Arborists often work within the framework of these policies. They may be involved in evaluating trees for permits, developing protection plans, or ensuring compliance during construction. Understanding local regulations is an important part of professional practice. Now let's consider the role of policy in urban forestry. Policies help balance competing interests. Development, infrastructure, and tree preservation often conflict. Tree ordinances provide a structured way to manage these conflicts. They help ensure that the long-term benefits of the urban forest are considered. For the ISA Urban Forest Professional Exam, focus on the role of policies and ordinances. You should understand the purpose of tree ordinances, common elements such as permits, protection, and replacement, the concept of protected trees, and how policies support urban forest management. Questions may involve identifying how regulations influence tree care decisions. Tree protection policies are a critical part of urban forestry. They ensure that trees are not just maintained, but valued and protected over time. In the next podcast, we'll continue with arboricultural practices by exploring tree risk mitigation strategies and how arborists apply multiple tools to manage risk in urban environments. In the previous podcast, we discussed tree protection policies and how ordinances guide tree management in urban environments. Today, we're returning to a core arboricultural responsibility: managing risk. But this time, we're focusing specifically on mitigation, because identifying risk is only the first step. The real challenge is deciding what to do about it. Tree risk mitigation involves applying strategies to reduce the likelihood of failure, reduce the chance of impact, or reduce the severity of consequences. The goal is not to eliminate risk entirely. That is not possible. The goal is to reduce risk to an acceptable level. Let's start by reviewing the three components of risk: likelihood of failure, likelihood of impact, and consequences. Mitigation strategies can target one or more of these components. For example, pruning can reduce the likelihood of failure. Changing site use can reduce the likelihood of impact. And in some cases, removing a tree eliminates the risk entirely. Now let's look at the most common mitigation strategies. The first is pruning. As we discussed in earlier podcasts, pruning can remove deadwood, reduce end weight, and improve structure. By reducing mechanical stress, pruning lowers the chance that a branch or tree will fail. Next is support systems. Cabling and bracing can provide additional stability to trees with structural weaknesses. These systems reduce movement and help prevent failure. However, they must be installed and maintained properly. Now let's consider site modification. In some cases, risk can be reduced by changing how an area is used. For example, restricting access beneath a tree can reduce the likelihood of impact. Moving a bench or redirecting a pathway can lower risk without altering the tree itself. Another strategy is monitoring. Trees with known defects may not require immediate action. Instead, they may be inspected regularly to track changes. If conditions worsen, additional actions can be taken. Monitoring allows arborists to manage risk over time. Now let's talk about removal. Tree removal is the most definitive risk mitigation strategy. If a tree presents an unacceptable level of risk and other options are not sufficient, removal may be necessary. As we discussed in Podcast 40, this decision should be made carefully. Now let's consider prioritization. Not all risks can be addressed at once. Arborists must prioritize based on factors such as tree condition, location, and target use. High-risk trees in high-use areas are typically addressed first. Now let's talk about communication. Risk mitigation decisions often involve stakeholders. Residents, property owners, and city officials may be affected. Clear communication is essential. Arborists must explain the nature of the risk and the reasons for management decisions. This helps build understanding and trust. Now let's connect this to urban forestry. Risk mitigation is an ongoing process. Trees grow, conditions change, and new risks develop. Effective management requires continuous assessment and adaptation. For the ISA Urban Forest Professional Exam, focus on mitigation strategies. You should understand how pruning reduces risk, the role of cabling and bracing, how site modification affects risk, when monitoring is appropriate, and when removal is necessary. Questions may involve selecting the most appropriate mitigation strategy for a given scenario. Tree risk mitigation is about making informed decisions. It is about balancing safety with preservation. And it is about using the right tools to manage risk over time. In the next podcast, we'll continue with arboricultural practices by looking at emergency response and how arborists manage trees after storms and other unexpected events. In the previous podcast, we discussed tree risk mitigation and how arborists reduce risk through pruning, support systems, and management decisions. Today, we're going to focus on what happens when those risks become reality. Storms. Emergency response is a critical part of arboriculture, especially in urban environments where trees and people exist in close proximity. Storms can cause widespread damage to the urban forest in a very short period of time. High winds, heavy rain, snow, and ice can all lead to tree failure. Branches may break. Entire trees may uproot. Infrastructure can be damaged. Roads can become blocked. And public safety becomes the top priority. Let's start with the immediate response. After a storm, arborists are often part of emergency management teams. Their first responsibility is to assess hazards. This includes identifying trees or branches that pose an immediate threat. For example, a partially broken limb hanging over a roadway is a high-priority hazard. A tree that has fallen and is blocking access for emergency vehicles must be addressed quickly. The focus at this stage is not on long-term tree health. It is on safety and access. Now let's talk about prioritization. Not all damage can be addressed at once. Arborists must prioritize based on risk and impact. Critical infrastructure such as roads, hospitals, and utility corridors are addressed first. Areas with high public use are also prioritized. Lower-risk areas may be addressed later. Now let's consider the types of storm damage. Broken branches are one of the most common issues. These may require pruning to remove damaged wood and restore structure. Uprooted trees are another major concern. When a tree is uprooted, its root system is compromised. In most cases, these trees cannot be saved and must be removed. Stem failure is also common. This occurs when the trunk breaks or splits. Depending on the severity, the tree may be removed or stabilized. Now let's talk about post-storm assessment. Once immediate hazards are addressed, arborists evaluate the remaining trees. Some trees may have hidden damage. For example, root systems may be partially compromised, even if the tree is still standing. Cracks or internal damage may not be immediately visible. These trees require careful inspection. Now let's consider recovery. After a storm, arborists may perform corrective pruning to improve structure. This helps the tree recover and reduces future risk. In some cases, cabling or bracing may be installed to provide additional support. Now let's talk about long-term implications. Storms can significantly alter the structure and composition of the urban forest. Large canopy trees may be lost. This affects shade, cooling, and ecosystem services. Recovery may take years or decades. This is why resilience is so important. As we discussed earlier, species diversity and proper tree structure can reduce storm damage. Now let's connect this to planning. Urban forestry programs often develop emergency response plans. These plans outline roles, priorities, and procedures for storm events. Having a plan in place improves response efficiency and safety. For the ISA Urban Forest Professional Exam, focus on emergency response principles. You should understand how arborists prioritize work after a storm, the types of storm damage when trees can be salvaged versus removed, and the importance of post-storm inspection. Questions may involve identifying appropriate responses to storm damage scenarios. Storms are a reminder that trees are dynamic living systems. They grow, adapt, and sometimes fail. How arborists respond to these events shapes the future of the urban forest. In the next podcast, we'll continue with arboricultural practices by exploring urban tree planting programs and how cities scale planting efforts to build canopy over time. In the previous podcast, we explored emergency response and how arborists manage storm damage in urban environments. Today, we're shifting from response to growth, urban tree planting programs. Because while storms and removals reduce canopy, planting programs are what rebuild and expand the urban forest over time. Tree planting is one of the most visible parts of urban forestry. But successful planting programs are more than just putting trees in the ground. They require planning, coordination, and long-term management. Let's start with the purpose of planting programs. At a basic level, they aim to increase canopy cover, but they also serve other goals. These may include improving air quality, reducing heat, managing stormwater, and enhancing community well-being. Planting programs are often tied to broader city goals, such as climate action plans or sustainability initiatives. Now let's talk about planning. Effective planting programs begin with identifying planting opportunities. This may include streets, parks, public spaces, and private properties. GIS and inventory data are often used to identify areas with low canopy. These areas may be prioritized for planting. Now let's consider site selection. Not every location is suitable for planting. Arborists must evaluate available space, soil conditions, sunlight, and potential conflicts with infrastructure. As we discussed earlier, the right tree must be matched to the right site. Now let's talk about species selection. Planting programs should promote diversity. Avoiding over-reliance on a single species reduces vulnerability to pests and diseases. Species should also be selected based on site conditions and long-term performance. Now let's consider planting methods. Proper planting techniques are essential for success. This includes correct planting depth, proper handling of the root ball, and appropriate mulching. As we discussed in earlier podcasts, planting errors can lead to long-term problems. Now let's talk about scale. Urban tree planting programs often involve planting large numbers of trees. This may be done by city crews, contractors, or community volunteers. Managing large-scale planting requires coordination and organization. Now let's consider maintenance. Planting is only the beginning. Newly planted trees require care during the establishment period. This includes watering, mulching, and monitoring. Without proper maintenance, many newly planted trees fail. This is one of the biggest challenges in urban forestry. Now let's talk about community involvement. Many planting programs involve volunteers. Community engagement helps increase awareness and support for urban forestry. It also helps build a sense of ownership. Now let's connect this to long-term canopy goals. Planting programs must be aligned with removal rates. If more trees are removed than planted, canopy will decline. Cities must balance planting and removal to maintain or increase canopy. Now let's consider equity. As we discussed in earlier podcasts, canopy is not evenly distributed. Planting programs often focus on underserved areas with low canopy. This helps address environmental justice and improve community health. For the ISA Urban Forest Professional Exam, focus on planting program concepts. You should understand how planting programs are planned and prioritized, the importance of species diversity, the role of site selection, and the importance of post-planting maintenance. Questions may involve identifying factors that influence successful planting programs. Urban tree planting programs are how cities invest in their future. Every tree planted today contributes to canopy decades from now. But success depends on planning, proper planting, and long-term care. In the next podcast, we'll continue with arboricultural practices by looking at urban tree establishment programs and how cities ensure that newly planted trees survive and thrive. In the previous podcast, we discussed urban tree planting programs and how cities plan and implement large-scale planting efforts. Today, we're going to focus on what happens after planting. Establishment, because planting a tree is only the beginning. The real challenge is helping that tree survive and grow in its new environment. Urban tree establishment programs are designed to support trees during this critical period. Without proper establishment care, many newly planted trees fail. And when trees fail early, it undermines canopy goals, wastes resources, and reduces long-term benefits. So establishment is where planting success is truly determined. Let's start with a key concept: the establishment period. As we discussed earlier, a general guideline is that a tree requires about 1 year of establishment for every inch of trunk diameter. During this time, the tree is recovering from transplant shock and rebuilding its root system. Because much of the root system was lost during transplanting, the tree is highly vulnerable. Now let's talk about the primary needs during establishment. Water is the most critical factor. Newly planted trees require consistent watering. The goal is to maintain adequate soil moisture without overwatering. Too little water leads to drought stress. Too much water reduces oxygen in the soil and can lead to root problems. Establishment programs often include scheduled watering. This may be done by city crews, contractors, or community volunteers. Now let's consider mulching. Mulch helps retain moisture, regulate soil temperature, and reduce competition from grass and weeds. Proper mulching improves soil conditions and supports root growth. As we've discussed before, mulch should be applied correctly and not piled against the trunk. Now let's talk about monitoring. Newly planted trees should be inspected regularly. Arborists look for signs of stress, pests, or improper planting. Early detection of problems allows for corrective action. For example, if a tree is planted too deeply, it can be adjusted. If watering is insufficient, schedules can be modified. Now let's consider structural training. Young trees benefit from early pruning to establish good structure. This includes selecting a dominant leader and removing poorly attached branches. Early training reduces the need for more extensive pruning later. Now let's talk about protection. Newly planted trees are vulnerable to damage. This may include mechanical damage from equipment, animals, or vandalism. Protective measures such as tree guards or staking may be used. However, staking should be used only when necessary and removed once the tree is stable. Now let's consider program design. Urban tree establishment programs often include defined maintenance periods. For example, a city may provide care for the first 2 to 3 years after planting. After that, responsibility may shift to property owners or general maintenance programs. Clear responsibilities are important. Now let's connect this to survival rates. Tree survival is a key metric in urban forestry. High mortality rates indicate problems in planting or establishment practices. Improving establishment care increases survival and improves program effectiveness. Now let's connect this to long-term outcomes. Trees that establish successfully grow faster, develop stronger structures, and provide benefits sooner. They are more likely to become mature trees that contribute significantly to canopy. For the ISA Urban Forest Professional Exam, focus on establishment concepts. You should understand the importance of the establishment period, the role of watering and mulching, the need for monitoring and early intervention, and the importance of structural training. Questions may involve identifying practices that improve survival of newly planted trees. Tree establishment is where planting efforts either succeed or fail. It is the bridge between planting and long-term growth. With proper care, a newly planted tree can become a long-term asset. In the next podcast, we'll continue with arboricultural practices by exploring pruning cycles and long-term canopy management, and how arborists maintain tree structure and health over time. In the previous podcast, we discussed urban tree establishment and how early care determines whether newly planted trees survive and grow. Today, we're going to move further along the tree life cycle, into long-term maintenance, specifically pruning cycles and canopy management. Because while early care is critical, trees require ongoing management throughout their lives. And pruning is one of the most important tools arborists use to guide that growth. Let's start with a key idea. Pruning is not just about removing branches. It is about directing growth, improving structure, and managing risk over time. In urban forestry, pruning is often organized into cycles. A pruning cycle is a scheduled system where trees are pruned at regular intervals. For example, a city may operate on a 5 or 7 year pruning cycle. This means that each tree is pruned once during that period. The purpose of a pruning cycle is consistency. Instead of reacting to problems as they arise, arborists proactively maintain tree structure and health. Now let's talk about how pruning objectives change over time. Young trees require structural pruning. This focuses on developing a strong framework. Arborists select a dominant leader, space branches appropriately, and remove defects early. This reduces the likelihood of future structural problems. As trees mature, pruning objectives shift. The focus becomes maintenance pruning. This includes removing deadwood, reducing risk, and maintaining clearance from infrastructure. In mature trees, pruning must be done carefully. Excessive pruning can stress the tree and reduce its ability to produce energy. Now let's talk about canopy management. The urban canopy is not just a collection of individual trees. It is a system. Managing canopy involves maintaining overall structure, density, and distribution. Pruning plays a role in shaping how the canopy develops over time. For example, maintaining clearance over roads and sidewalks ensures safe access. Managing canopy density can improve light penetration and reduce wind resistance. Now let's consider risk management. Regular pruning reduces the likelihood of branch failure. Removing dead or weak branches lowers risk. Reducing end weight on long limbs decreases mechanical stress. This is especially important in areas with high public use. Now let's talk about timing. Pruning can be performed at different times of year depending on species and objectives. Dormant season pruning is common because it reduces stress and improves visibility of structure. However, some pruning may be done during the growing season. Timing may also be influenced by pest and disease considerations. Now let's consider efficiency. In large urban forestry programs, pruning cycles help organize work. Crews can move systematically through areas. This improves efficiency and ensures that all trees receive attention. Now let's connect pruning to long-term outcomes. Trees that are pruned regularly develop stronger structure. They require less corrective work later. They are less likely to fail during storms, and they provide more consistent benefits. Now let's connect this to canopy goals. Maintaining canopy is not just about planting trees. It is about sustaining them over time. Pruning is one of the key practices that supports long-term canopy health. For the ISA Urban Forest Professional Exam, focus on pruning concepts. You should understand the purpose of pruning cycles, the difference between structural and maintenance pruning, how pruning reduces risk, and how pruning supports long-term canopy management. Questions may involve identifying appropriate pruning strategies for different tree stages. Pruning is one of the most powerful tools in arboriculture. It shapes how trees grow, how they function, and how they interact with the urban environment. In the next podcast, we'll continue with arboricultural practices by exploring tree removal cycles and replacement planning, and how cities manage the transition from aging trees to new canopy. In the previous podcast, we discussed pruning cycles and how arborists maintain tree structure and canopy over time. Today, we're going to look at another part of long-term urban forest management, tree removal cycles and replacement planning. Because while pruning helps extend the life of trees, no tree lives forever. Urban forests are constantly changing. Trees age, decline, and eventually must be removed. The key is managing that process strategically. Let's start with a core concept. The urban forest is a population, not just individual trees. This means arborists must think in terms of life cycle management. Trees are planted, established, mature, decline, and are eventually removed. Removal is not a failure. It is part of the cycle. Now let's talk about removal cycles. In many urban forestry programs, removals are not handled randomly. They are planned. Inventory data helps identify trees in poor condition, high-risk trees, or trees nearing the end of their lifespan. These trees can be scheduled for removal in an organized way. This allows cities to manage workload and budget more effectively. Now let's consider the timing of removal. Some removals are reactive, for example, after a storm, or when a tree becomes hazardous, but others are proactive. A tree that is declining may be removed before it becomes a safety risk. Proactive removal can reduce emergency situations and improve safety. Now let's talk about replacement planning. When a tree is removed, the question becomes, what replaces it? Replacement planning ensures that canopy is maintained over time. Without replacement, canopy will decline. Replacement planning involves selecting appropriate species, identifying planting locations, and coordinating planting efforts. Now let's consider timing. In some cases, replacement planting occurs immediately after removal. In other cases, it may be delayed due to site conditions or seasonal factors. Now let's talk about species selection. Replacement trees should contribute to diversity. If a particular species has been overrepresented, replacement planting can help rebalance the population. This reduces vulnerability to pests and diseases. Now let's consider spacing and distribution. Replacement planning is not just about replacing individual trees. It is about maintaining canopy distribution across the city. Some areas may require more planting to achieve equity and coverage goals. Now let's talk about age distribution. As we discussed earlier, a balanced age structure is important. If too many trees are the same age, they may decline at the same time. Replacement planning helps create a more balanced population. Now let's connect this to long-term canopy goals. Urban forestry programs often set canopy targets. These targets require both planting and preservation, but they also require strategic replacement. If removals outpace planting, canopy declines. If planting is well planned, canopy can be maintained or increased. Now let's consider budgeting. Tree removal and replacement both require resources. Planning helps cities allocate funds effectively. It also helps avoid sudden spikes in workload. Now let's connect this to sustainability. A well-managed removal and replacement cycle supports a stable, resilient urban forest. It ensures that benefits are maintained over time. For the ISA Urban Forest Professional Exam, focus on life cycle management. You should understand the concept of removal as part of the tree life cycle, the difference between reactive and proactive removal, the importance of replacement planning, and how removal and planting affect canopy. Questions may involve evaluating strategies for maintaining canopy over time. Tree removal is not the end of the urban forest. It is part of its renewal. Through careful planning, arborists ensure that each removal is followed by new growth. In the next podcast, we'll continue with arboricultural practices by exploring urban forest sustainability and how all these practices come together to support long-term forest health. In the previous podcast, we discussed tree removal cycles and replacement planning and how arborists manage the life cycle of trees over time. Today, we're going to step back and look at the bigger picture: urban forest sustainability. Because all of the practices we've covered, planting, pruning, soil management, risk assessment, are part of something larger. A long-term system. Sustainability in urban forestry means maintaining a healthy, functional, and resilient tree population over time. Not just for today, but for decades into the future. Let's start with a key concept: time. Urban forests operate on long time scales. A tree planted today may take 20, 30, or even 50 years to reach maturity. This means that decisions made now will affect future generations. Sustainability requires thinking beyond short-term results. Now let's talk about resilience. A sustainable urban forest is resilient. It can withstand stress, adapt to changing conditions, and recover from disturbances. Resilience is influenced by several factors. Species diversity is one of the most important. A diverse forest is less vulnerable to pests and diseases. If one species is affected, others can continue to provide benefits. Age diversity is also critical. A balanced age distribution ensures that canopy is maintained as older trees decline and new trees grow. Now let's consider environmental conditions. Urban environments are constantly changing. Climate change is increasing temperatures, altering precipitation patterns, and introducing new stressors. Urban forests must be able to adapt. This may involve selecting species that are more tolerant of heat and drought. It may also involve adjusting management practices. Now let's talk about resource management. Sustainability requires efficient use of resources. This includes water, labor, and funding. Urban forestry programs must balance costs with long-term benefits. Investing in proper planting and maintenance reduces future costs. Now let's consider ecosystem services. As we discussed earlier, urban trees provide many benefits. These include cooling, air quality improvement, stormwater management, and carbon storage. A sustainable urban forest maintains these services over time. Now let's talk about monitoring and evaluation. Sustainability requires ongoing assessment. Arborists must track tree health, canopy cover, and population trends. This helps identify problems and guide future actions. Now let's consider community involvement. Urban forests exist within communities. Public support is essential. Engaging residents in planting, care, and decision-making helps sustain the urban forest. Now let's connect this to policy. Policies and planning frameworks support sustainability. They ensure that trees are considered in development and land use decisions. Now let's bring all of this together. Sustainability is not one action. It is the result of many coordinated efforts. Planting, preservation, risk management, and planning all contribute. For the ISA Urban Forest Professional Exam, focus on sustainability concepts. You should understand the importance of long-term planning, the role of diversity and resilience, how climate affects urban forests, and how management practices support sustainability. Questions may involve identifying strategies that support long-term forest health. Urban forest sustainability is about stewardship. It is about caring for a living system over time. And it is about ensuring that future generations inherit a healthy and functional urban forest. In the next podcast, we'll conclude this section by bringing together the key concepts of arboricultural practices and how they support the overall goals of urban forest management. In the previous podcast, we explored urban forest sustainability and how long-term planning supports a resilient and functional tree population. Today, we're going to bring everything together. This podcast is about integration, because arboriculture and urban forestry are not separate disciplines. They are interconnected parts of the same system. Arboricultural practices, everything we've covered from planting to pruning to risk assessment, are the operational tools that make urban forest management possible. Let's start with a simple idea. Urban forestry is the strategy. Arboriculture is the practice. Urban forestry defines the goals. Arboriculture is how those goals are achieved on the ground. For example, a city may set a goal to increase canopy cover. That goal is part of urban forest management, but achieving it requires arboricultural practices. Tree selection, planting, establishment care, maintenance. Without those practices, the goal remains theoretical. Now let's connect this to life cycle management. As we discussed in earlier podcasts, trees move through stages. They are planted, established, mature, decline, and are eventually removed. At each stage, arboricultural practices are applied. Young trees require establishment care. Mature trees require pruning and monitoring. Declining trees require risk assessment and decision-making. This life cycle approach is central to urban forestry. Now let's consider data and planning. Urban forestry relies on data such as inventories and canopy assessments. But data alone does not manage trees. It informs decisions. Arboricultural practices are what implement those decisions. For example, inventory data may identify trees that require pruning. Arborists then perform that pruning. This connection between data and action is essential. Now let's talk about risk management. Urban forestry programs aim to maintain safe tree populations. Arborists assess risk, apply mitigation strategies, and monitor outcomes. This reduces hazards while preserving tree benefits. Now let's consider environmental benefits. Urban forestry recognizes trees as infrastructure that provide ecosystem services. But those services depend on tree health. Arboricultural practices support that health. Proper planting ensures survival. Soil management supports growth. Pruning maintains structure. All of these practices contribute to the ability of trees to provide benefits. Now let's talk about scale. Urban forestry operates at the population level. Arboriculture operates at the individual tree level. Integration means connecting these two scales. Decisions made for individual trees must align with broader program goals. Now let's consider communication. Arborists often serve as the link between technical knowledge and public understanding. They explain why trees are pruned, removed, or protected. This supports public trust and engagement. Now let's connect this to policy. Policies and ordinances define how trees are managed. Arborists apply these policies in practice. They ensure compliance and help achieve program objectives. Now let's bring everything together. Urban forest management is a system. It includes planning, data, policy, and community engagement. Arboriculture is the set of practices that make that system work. Without arboriculture, urban forestry cannot function. For the ISA Urban Forest Professional Exam, focus on integration. You should understand how arboricultural practices support urban forestry goals, the connection between data and field operations, how life cycle management works, and how individual tree care contributes to population-level outcomes. Questions may involve identifying how practices align with broader management strategies. Arboriculture is where theory meets reality. It is the hands-on work that shapes the urban forest. And when it is guided by thoughtful planning and long-term vision, it becomes something more. It becomes stewardship. This concludes the arboricultural practices section and sets the foundation for understanding how trees are managed, maintained, and sustained in urban environments. You've been listening to the Arborist Podcast. Our goal is to grow our collective knowledge, one domain at a time. If you enjoyed the podcast, please like, share, and subscribe to help us keep this momentum. Until next time, let's keep growing this community together.